What is data analytics? Data analytics is the buzzword you would have heard a lot about in the recent years. To put it simply, it's the process of analyzing raw data to get insights and find patterns about the information. Using various techniques and processes, the raw data is transformed into a format which could be further visualized and be made human readable. To understand the definition in an even clear way, let's take a look at this example. John, who is a digital marketing professional, is running an online advertising campaign to promote a new smart television. John starts by targeting the group of people who might have bought the previous versions of the smart TV in question. As said campaign runs, data analytics comes into the picture through the data generated whenever people clicked on the published advertisement. Now, by inspecting the data about these users' interest and their buying patterns, you might come across that many of them are interested in streaming 4K UHD video. The reason behind this might be that the new smart TV has a better streaming quality than the previous versions. Using this information, you could tune in your advertisements to focus on users who bought the previous version of the smart TV and are interested in getting 4K streaming quality. This data can also be used to attract new customers who did not go for the previous version of the smart TV but are very interested in a better version of the TV. Why is data analytics significant? Businesses use data analytics to optimize and grow by making better business decisions and finding more efficient ways of doing business. The company can build new and better products with the buying patterns and better understanding what the customers need. So how do data analytics work? The data analytics process has some components that can help a variety of initiatives. By combining these components, a successful data analytics initiative will provide a clear picture of where you are, you have been, and where you should go. Generally, this process begins with the descriptive analysis. This is the process of describing historical trends in data. Descriptive analytics aims to answer the question, what happened? This often involves measuring traditional indicators such as return on investment. The indicators used will be different for each industry. Descriptive analytics does not make predictions or directly inform decisions. It focuses on summarizing data in a meaningful and descriptive way. The next essential part of data analytics is advanced analytics. This part of data science takes advantage of advanced tools to extract data, make predictions, and discover trends. These tools include classical statistics as well as machine learning. Machine learning techs such as neural networks, natural language processing, sentiment analysis, and more enable advanced analytics. This information provides new insight from data. Advanced analytics addresses what if the question. Data analytics affects every aspect of our day-to-day lives. You may not even realize it, but you probably use data analytics almost every day. Here are some of the everyday applications of data analytics. Social media stats instantly register anytime there's a visitor or a post to a page. Cell phone bills can pull up months of calling data to show you patterns of usage. Sensors monitor the changing weather and report the data to you instantly on your smartphone. Sports fans collect statistics on their favorite athletes and often use the data to form the term of fantasy leagues. Schools across the nation are involved in high-stakes testing that generates voluminous data on each student's progress. Educators then utilize data generated from extensive reports to drive their instruction. Data analytics is a growing field and will always be a top domain to get into. The average salary of a data analyst in India is 7 LPA and in the US it's $70,000. There are 27,000 plus data analytics jobs available only on LinkedIn, and there are very few skilled professionals to fill that gap.
Hello everyone and welcome to today's session on Data Analytics with R by Intellipaat. Data analytics refers to qualitative and quantitative techniques and processes used to enhance productivity and business gain. Data is extracted, acknowledged, and bifurcated to identify and analyze behavioral data, techniques, and patterns. R is a language and environment for statistical computing and graphics. It is a suite of software facilities for data manipulation, calculation, and graphical display. In this session, you will learn all about data analytics using R. So let's check the agenda for the session. First, we'll learn about what is data analytics and types of data analytics. Next in this session, we'll know about role of data analytics in industry. After that, data manipulation with R programming and data visualization with R programming. Later in this session, we'll talk about transpose function in R, reading data from external files, and bar plots. At last, we'll discuss on how to generate a histogram, and most important, data analytics job scope and salary. But before that, please subscribe to our YouTube channel and hit the bell icon so you never miss an update.
We've all heard this term somewhere. It pretty much rings a bell that every time we think about it, right? So, analytics with respect to data. Well, what are we trying to analyze is what we need to know here, right? So, the formal definition of how it goes, it's basically extracting meaningful information from raw data. It's as simple as that. So we have data, right? So consider anything to be data. If that is not useful to you at that point, it is considered as data. But then if you perform some operation on this data and make sure that it is useful for your organization, this is when the data becomes information. And this information is what is usable for you, right? So the process of pretty much converting raw data into information by performing certain analysis on it can be termed as data analytics, guys. I mean, this is just a very rough definition of what goes in the industry. To give you a better insight of what that means, basically it is the pursuit of extracting meaning from raw data using specialized computer systems, guys. And then these systems, they transform, they organize, and they model the data. End of it is to basically draw the conclusions from all of the data. So you'll have, again, as I've mentioned with the raw example, our goal here is to basically draw conclusions, to identify patterns, to make use of this raw information in a better way. I mean, sure, data can just be used in its raw form, but then not with every case, right? And to give you an example, so think of the data, probably you understand. So let's say you're looking at a huge data set which contains thousands of values. Those are just numbers, right? So having these numbers, sure, as a data analyst, you will understand what you're doing. But then let's say you need to explain it to a person who doesn't know what data analytics is, or you need to explain it to someone, probably your peer or someone above you as well. Let's say you have a business meeting where you have to explain this. Giving the numbers will not really be that great, right? It will not make a very good presentation. So converting all of these numerical data, making it into graphs, making it in a way where everyone understands the data, and showing out graphically whatever insights that you can generate from the data, that can be considered as data analytics as well, guys. Again, today basically the field of data analytics is ever so growing rapidly. And why is it growing so rapidly? Well, because the market demand for it is that much. So we have pretty much every startup companies these days have a requirement for big data as well. So big data, to dumb down the definition, it pretty much means a huge amount of data that cannot be handled by just one machine. If you're stretching out your data across multiple nodes, you have data coming in from various sources. Then you need a method to handle all of this big data that's coming in, to process the data and then to perform analysis on it, guys. So this has been in demand in the market for a while, and for the last couple of years, data analytics has been in the boom, and then it's providing a very straight answer to all of the questions being raised about how all these can be handled, guys. And of course, we're going to need the people who have the skills which is needed, skills which are needed to manipulate all the data queries, to translate all these numbers into graphs, and to make insightful analysis on it, right? So that's what is the main key role of a data analytic person. What is the need for data analytics if we have to break it down into 3 steps, guys? So again, we already know that it is on the rise, right? So I can pretty much go about to step out into the open and then tell you that it is not soon that it will be an integral part of an organization. It is already an integral part of every organization there is, guys. So the first important need is, again, we already know that it is a top priority for all of these organizations, ranging from the small organizations all the way till the big guys. And then this is needed to make very good decision making. Well, with respect to you being confused to, let's say, take a decision for you, then looking at this analytics will make your decision making skills and decision taking skills a little bit easier, and it'll be more validable as well, guys. And it'll be more validated as well, guys. And the second thing is to we require new revenue, right? So let's say you have the data which pretty much only a couple of people can make sense of understand. Let's say your market is very niche. In that case, sure, you'll be still making revenue, still be making money on it. But then at the end of the day, if you have to reach out to a broader audience, you need to make sure your data is understood by this broader audience, right? So that forms the second very important need for data analytics, guys. And the third one is to obviously decrease these operation costs for every organization. So this can be a very demanding task if you have to convert raw data into information, process the data, and make out very good visualizations out of it as well. But then if you have the workforce for it, then sure, you can do it. But if not, again, since it's probably a manual task, and until a couple of years ago, it surely was a manual task. And these days you can implement machine learning and data analytics to pretty much automate itself and make your job easier as well. It speeds up your work. It keeps you very efficient in such a way where your data is being visualized, processed very effectively. So again, time is money when it comes to big organizations, right? So on that note, pretty much it helps decrease all of the operational costs with respect to, either waiting in the data pipeline or waiting to process, waiting to publish, waiting to do some analytics, waiting for visualization. All of these waits, you need not consider them anymore because they will pretty much be reduced to null, guys. So on that note, you might be wondering, who are data analysts, right? So data analysts are the people who sit at the end of the chain. I'll just explain the chain in the next slide. So these guys form a very good workforce for the company where they basically, deliver the values by taking in all the data that data scientist might give it to them, a data engineer might give it to them. And then he uses this person, data analyst uses all of these to answer a couple of questions and then communicate all of the results back. And all these results that he just gives back is basically used to take very good business decisions, guys. It might include analytics of past trends, it may be prediction of what the future looks like, and so much more. And then the common tasks done by data analysts are data cleaning, performing analytics, and then creating visualizations. Well, data cleaning to come about it is basically simple, guys. So again, data is raw information, right? To make sense out of it, to pick out information that we only require, and to make sure that again efficiency is the game here. If you're pretty much processing data that we pretty much will not require, then it's just a waste of time and resource. So cleaning the data, making sure that your data is just perfect enough for processing, that's a very important first step, guys. So this is the spearhead of a data analyst's role. And then the second one is obviously, as soon as your data is clean, you need to perform some very good analytics on it and create very good visualizations, guys. So these four designations you see on the screen right now is basically the designations a data analyst is also known by. So the first is a business analyst. So data analyst is also a business analyst. He or she can be an operations analyst, a business intelligence analyst, and a database analyst as well, guys. So coming to the tasks that they pretty much do, the first important task that we already spoke about was cleaning and organizing raw unstructured data, right? So this is again a very overlooked concept in today's world unless you get your hands dirty with the data itself. When you start to go about doing that, you will realize that cleaning and organizing the raw data is extremely important, because at the end of it, your data might be unstructured, your data might be semi-structured, or it might be a structured data. This will not matter if the data you're processing is of no use at the end, guys. So cleaning and organizing raw data is very important. And then the second thing is the analysis of all of the hidden trends found in the data. So making sense of something, again, maybe predictions in the future, or looking at past trends, generating this sort of an information which you cannot figure out upfront just by looking at the data. This is pretty much the umbrella under which the hidden trends function of a data analyst's work. So you'll be looking at a data, you'll find something very interesting. So let's say you find a trend in your data where pretty much you can access a new side of the market with respect to your sales in the next 5 years, 10 years. And then you were not told this, but then your data was telling you this. So you making sense of the data in which this trend was found, which was not upfront, then this is again a very important skill of a data analyst as well, guys. And the third important thing is pretty much the big picture view using descriptive statistics. At the end of it, sure, we know what the past trends of the company are, we know how the company is going on now, but then if you need to just summarize all of this and say even add some predictions for the next 5-10 years, getting this big picture view of what's happened, what's happening now, and what will happen in the future, not just using very simple statistics, but using descriptive statistics where we'll be picking up each aspect of what's going on and then perform analytics on it and find out what's going on. If we are right at this place, if we are wrong at this place, how can this be improved? How can this concept be checked? How can we reach the clients better, and so much more. So getting this big picture view is again a very important task data analyst goes about doing, guys. And the fourth one is probably the most important thing a data analyst does, is pretty much the creation of dashboards and visualizations, guys. So as I already told you in the introduction part of the video, where we're starting out with raw information, again a lot of numbers, but if you have to show these numbers at a business meeting, numbers are numbers, some people like them, but a majority of the people who they might not understand the numbers. So making these numbers as your input, creating very good visualizations, giving them a user interface, and giving your customers, your peers, your superiors, your business meeting members, giving them a very good user experience with all of this data. Again, at the end of it will add up to very good business methodologies, and then it will help you take better business driven decisions again. And again, the same goes for presentations of results to your clients and your internals as well, guys. So coming to the chain of how the data moves around in a firm, I have 3 important things that I just want to walk you through, guys, in a quick gist. So the first person who is the spearhead of the data for an organization. By spearhead, I mean he's the first one who look at the data, or he'll be responsible for bringing in all of the data from various sources, guys. So data coming in from the various sources, right? So think about all the data you can get from Twitter, or if you're performing any sentiment analysis, think of all the data that can come from all of the big data sources. You can have data coming from your various nodes from Hadoop, so much more. You can have your data coming from your own network, away from your network, and so much more, guys. So the data engineer is a spearhead who handles bringing in the data and making it understandable by the organization, guys. And then as soon as the data engineer finishes his part with the data moves on to the data scientist. The data scientist, he's responsible for working on all of these raw data, converting it into valid information. But then we already told this for the data analyst as well. Well, the data scientist pretty much uses machine learning algorithms. He uses deep learning. He uses, let's say, binary classifications, naive bias. He makes use of so many concepts here that a data analyst might not know. And he uses a lot of machine learning and deep learning, as I've already mentioned, to convert this raw data into valid information. And 99% of the time, the information which is being converted into are numbers, guys. So after the data scientist pretty much goes about doing his magic onto the data, and then we have the data analyst who steps in. This person, again, as we've already been mentioning, he is responsible for the prediction of what happens in the future, that is finding out trends, and then the presentation of all these informations to your peers, to your clients, to your superiors, and so much more. This is the basic gist of how data moves around. So the data is first seen by the data engineer. He does his job, comes to the data scientist. The data scientist works his magic via all these fancy algorithms and whatnot, and then pushes the data to the data analyst. The data analyst performs predictions, sees trends, visualizes the data, makes it presentable for everyone to understand, and then eventually goes about analyzing the data, guys. So on that note, we can come check out the type of data analytics that can be done in today's business, guys. There are a couple of types of data analytics, and I'll be walking you through the same. So the first type of data analytics you can go about doing is the descriptive analytics. With respect to descriptive analytics, again, the quick phrase answer to what descriptive analytics is basically picking out data from a source, summarizing your data, making sure your data can be understood by everyone, that is picking out very good insights from your data, from all the past events, doing some predictive analytics on that as well, and then keeping it ready so your data is descriptive at the end of the day. And a question which goes by to understand the descriptive analytics is what happened in my business. So the answer to this question, what happened in my business, is given to by the descriptive analytics, guys. So most of the time the data which is generated by descriptive analytics is very comprehensive, it is extremely accurate, and the visualizations are very effective as well. So here's a very simple scenario that you guys can consider. So consider a scenario where an e-learning website decides to focus on a trending course according to the analytics of the search volume of the course content, which pretty much the users go on searching, and all of the revenue generated by the course in the past few months as well. So there are certain technologies, again, we live in a world full of trends, right? So let's say data science is in the boom right now. So pretty much any e-learning company, or any company for that matter, they're going to find these trends. They're going to know that, hey, data science is sitting in the top tier and we need to do something about it. If they have students in data science, then most of these companies are aimed at making the students' life better, right? So even as a firm here in Intellipaat, that's exactly what we do as well. We get this amazing insight from all of our learners for any particular course, and we use all of those insights, all of the feedback that we get, and what's trending in the market, what's latest in the market, and we use all of these to perform analytics, and then pretty much all of these helps us to put out a better course as well, guys. So at the end of it, you can already see how the descriptive analysis is already helping our business, right? And then the next type of data analytics we can check out is the diagnostic analytics, guys. So we already checked out what is happening to my business with respect to descriptive analytics. With respect to diagnostic analytics, you will check out of why this particular thing is happening to my business, guys. To simplify it again, it basically gives you the ability to drill down to the root cause of why something is behaving just like how it should, guys. So drilling down the data to identify certain set of problems which are present in your data or in the trends that the data shows is a very vital part of diagnostic analytics, guys. And then it basically helps in answering the question for us about why the issue has occurred, So it just takes one look towards the data, towards the analytic result of the data, to understand what the cause behind a problem, if one should exist, as guys. So again, to give you a very simple scenario of how diagnostic analytics would work, let's say consider a company where the sales went down for a month. So let's say they weren't doing as good as the previous months. So to diagnose this particular problem, you will let's say consider the situation where the number of employees were quitting their job and they weren't bringing in a lot of sales. So this could pretty much, this number of people quitting the company could directly impact the sales that they brought into the company. So the sales went down this month because they did not have the company right. They did not have the sales right. So finding out why this is happening and hunting for that root cause, which is basically a treasure hunt with your data, where you go on finding something and taking insights from your data. Finding out that why part of it is extremely important, where you'll be finding out what's happening to the data and why it's behaving this way, guys. So this again is a very vital part of diagnostic analytics. And coming to the third type of data analytics, it is predictive data analytics, guys. And as the name suggests, the quick question you'll be asking is what will happen in the future based on the past trends, guys. So hunting out historical patterns that are being used to basically predict all these specific outcomes using let's say machine learning algorithms, using deep learning, and using so many more concepts to predict something in the future based on the data we have now is again a very important niche of data analytics, guys. So predicting the future trends and the possibilities in the market based on the current trends, self-explanatory. And then it helps in optimizing all of the business plans for the future, because now your business has a direction to head to, right? So you're predicting certain aspects in the future and you know which path leads to better business strategies, right? And this will give you an edge over all of the other businesses as well. To give you a very nice example, think of the Netflix recommendation systems, guys. So this will basically use statistical modeling to analyze all the content that it's being watched by the audience across the world. So let's say there are a couple of TV shows which are very famous in India, but then there might be a couple of TV shows which is trending in the United States, and let's say Australia, United Kingdom, so much more. Making sure that the right users in the right geographical area get to know the right recommendations are extremely important for Netflix as a business, right? So this again, predictive analytics will just do them good there, guys. Again, it will provide us with the prediction of all of the upcoming content and the shows that must be watched by all the different class of audience as well. So let's say someone sitting in the United States is very interested in watching an Indian trending television series as well. So knowing Netflix, finding out that this person exists and to recommend an Indian TV show for this person sitting in the United States to watch. Again, this is another very good business opportunity for Netflix. And then if they go about nailing their recommendation system for everyone, it just makes them a better business model, and then it just makes a better user environment for the users to go about watching videos there, guys. So the next type of data analytics is prescriptive data analytics. So as soon as we think of a prescription, again, we think of a doctor, we think of something, a medical appointment or something, right? Here it's again something similar. The question which will be asked here is what should be done? So applying advanced analytical algorithms to ensure that you make very good recommendations, you make sure you're punching out very good strategies that help the business, and so much more is a very vital part of prescriptive analytics, guys. So it basically involves breaking down all of this complex information into a very simple set of steps. And these steps are like the prescription we handed out when we visit the doctor, right? And these are the prescriptions which are precautious as well. Let's say that the precautions basically used to remove any of the future problems that might occur, and it will also help in performing predictive analysis. This will basically help to predict outcome, and eventually that will help us optimizing business as well, guys. So this again demands the use of artificial intelligence and big data, and then the data analyst person will always be in touch with the data engineer as well and the data scientist as well, because he's going to need all the help he can get with respect to artificial intelligence from the data scientist, and help with respect to big data from the data engineer as well, right? So all these three guys working in correlation make up a business, and I've already told you that. So again, to give you a common scenario of how this would happen, consider the prescriptive data analytics that Google Map goes about doing, right? So every day we are commuting from our office to our homes, or let's say we're going on a vacation and then we need to get out of the city as quick as possible. So Google Maps has a wonderful API where they map out the best possible route considering live traffic conditions, weather conditions, road closures, and so much more. It considers your distance, traffic constraints, and again, as I already told you, it even considers if it's raining, if you're walking, what's the best route that you can take to walk, what's the best route to take if you're in a car. And now they've come up with the bike route as well. So if you're in a moped or a bike, you can take a different route compared to the person who'd commute with the car, and so much more. So knowing this kind of a prediction into the future, and giving you the sort of a prescription to ensure you don't run into any problems along the way is a very important part of prescriptive data analytics, guys. So on that note, let's quickly check out what the life cycle of data analytics is like. So the data analytics lifestyle, it basically defines the analytics process and all of the best practices which goes on from the discovery of the data or the project till the completion of this project, guys. So there are a couple of steps involved in this life cycle process, and the first one is business understanding. At the end of it, again, understanding the purpose and all of the requirements that come from your business, and understanding it from the business viewpoint is very important and vital for the functioning of a business, right? This also consists of a very good introductory plan. It consists of a decision plan. It consists of a formal to-do list, let's say, for the business to go on to achieving the target. So the first important thing about the life cycle is the understanding of what's going on around you, and the second one is the data understanding, guys. With respect to data understanding, again, this mainly involves the process where we're collecting the data and we're processing the data in a way which leads to analytics. And then after the analysis of the data is done, we need to pick pick up some insights that we can go about using from the data. So extracting all of these meaningful insights from the data again is a very vital step in the life cycle of data analytics through data understanding, guys. The third part of it is data preparation. So data preparation is the let's say converting the data from an unstructured form to a structured form, and this involves constructing, let's say, a data set as well, and then this data set will be provided and fed into a model, and then this model will be used by a machine learning algorithm to train, to understand, to see what's going on, to perform predictions, and then it will be given to the data analyst to be visualized using Tableau or any other business intelligence tools and so much more. So data preparation again is a very important phase where the data is actually being transformed, and even at the stage the cleansing of the data is pretty much performed as well, guys. And then comes modeling. This step is very important because it involves the selection of various modeling techniques, applying all of these modeling techniques, making sure the parameters are right and all of the readings here are right to ensure that your data being converted into the information, raw data being converted into the information is of the optimal, let's say, it's of the optimal tolerance that can be used for your business usage. And then as soon as your modeling part of it is done, as soon as the techniques are applied and all the parameters are marked, then comes evaluation, guys. So evaluation is a very important phase where again the model which is being built, it will be built very rigorously, tested very rigorously based on what you've built in the initial stages, and then so many tests will be performed on this data as well. So evaluating something that you have generated, performing various tests on it is extremely important. Most of the time this is overlooked, but then these days everyone knows the value of evaluating your data, guys. So this again involves reviewing all of the steps that are again needed to carry out to construct this particular model and to perform tests on it is very important. And with evaluation, that's exactly what we do, guys. So the next life cycle concept I want to tell you guys is deployment. Deployment is the last step in the data analytics life cycle, because deploying is when you're sending out your model into the world for, let's say, by the world I mean, let's say, for your team, for your peers, or let's say even for your client and customers as well. So making your data go from just you seeing it all the way till spreading the data and performing spreading the data to your clients, to your peers, or anyone else. If you can perform more tests on these as well. So after deployment, you can have after deployment tests. If something is wrong, again you can go back to modeling, perform more evaluation, perform more deployment as well. So the thing you need to know here is that deployment pretty much goes about to be the final phase of the data analytics lifestyle, guys. And on that note, we can check out very quickly what are the roles of analytics in various industries around us, guys. Again, data analytics has an amazing insight and impact when it comes to the telecom industry, because again, if you've been observing, all the prices of or let's say the calls, the messages, or the internet packs these days have been coming down and down. And there was a time when they were being exorbitantly high as well. So again, the telecom industry realized that if you keep the prices very high to make more profits, then eventually your customers will not come. They will not buy the internet packs. So to keep this in mind, probably they decided, let's say we're having a bad impact right now, so let's drop down our prices to see if it works. And it is, I guess. And this has helped the telecom industry in bringing better business. And for us as users, this has helped us just make it a bit economical and efficient on our side with respect to money as well. And then the retail banking industry, data analytics has a huge impact in the retail banking industry as well, to know what their customer wants. Because again, with telecom industry as well, they have a huge amount of customers to play with, right? So they need to understand the view of each customer, the requirement of each customers, and then to find out if all of the customers are actually in the common chain of what's being supplied by the bank, or if the customers are against something that's being sent by the bank. So that again is a very important thing that you need to check here as well. And then with respect to the e-commerce industry as well, to perform again some analytics in the e-commerce industry, it might be ad recommendations, or there are very big sales which are run by some of the big names in the industry such as Amazon, Flipkart, Myntra, and so much more. So these guys will have to perform extremely heavy analytics on the data that they see based on the products that they sell and based on the places, based on the city in which the product sells, or if the people are unhappy with the price. Again, performing analytics has just changed the e-commerce industry, if you may, guys. And the last most important industry where data analytics has touched is the healthcare industry. This has had the most impact with respect to analytics in the healthcare industry with respect to so many things. Mainly it is with respect to finding out what medication is required by what countries, what amount of medication is working for what population, and so much more, guys. I can probably talk about just the roles of analytics in these industries for days together, and we can still be going on and have a very good discussion of how important analytics has become these days. Again, with respect to insurance as well.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following method creates a new array object that looks at the same data? A. View. B. Copy. C. Paste. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What geographical location requires insurance, what the audience are, and so much more. So again, as I've said, we can go on talking about this, but then to keep it to the scope of this tutorial, we can just quickly brief through each of these guys. So with respect to the healthcare industry, this is the formal way of going about analytics. The first one is to again analyze all of these disease patterns, analyze all of the disease outbreak that pretty much goes out. We had a disease outbreak a couple of years back, which is Ebola, and so much more. We had H1N1 and so much more, right? To keep a track of all of these outbreaks, this basically again improves the surveillance with respect to health, and then this gives out good responses to the emergency sectors as well, guys. And then development of better targeted preventive techniques, obviously, and then with the development of vaccines, making sure your vaccines again reach your customers, and all of these where you need to reach your customers, or let's say in this case the patients are very important, guys. So identifying the consumers again in this is the greatest risk of business. Identifying certain customers or patients who are at the greatest risk is again, because they might be developing some adverse health outcomes, and then developing welfare programs to keep a track of their health, to track their health on a daily basis, even a weekly basis, monthly basis, to perform analytics on all of the aspects and the parameters that you're tracking with respect to the patients. Again, that is a very important thing. And lastly, to ensure that they can reduce readmissions, because they might know what the cause of an adverse effect is, and if there are 10 patients with very similar symptoms, then you can perform analysis, and you can at least filter out and find out that all of these 10 patients might have this one common symptom associated with them, and this might be the cause of that. So mapping that for every patient is again very important, guys. So coming to the telecom industry, again, telecom industry pretty much goes about using predictive analysis to gain all of the insights that they need to make better decisions, to make faster decisions, and to make more effective decisions. Again, as I was talking about the internet pack example, again, this was very key in that. And then by learning more and more about their customers daily and the preferences and the needs, these telecom companies can be more successful in this extremely highly competitive industry as well. It's good for them with respect to business, and it is good for us as customers by bringing down the prices again. So it is used for analytical customer relationship management, it is used for fraud reduction, it is used for bad debt reduction, it's used for price optimization, call center optimization, and so much more. So now that you're looking at data analytics in this way, you realize that data analytics eventually has a big play or has a big say when it comes to any of these business models, right? So again, coming to banking, as I've already mentioned, analytics is making banks become very smart day by day, guys. So it is managing all of the plethora of challenges that the bank faces, and then again, while pretty much going about doing some basic reporting all the way till descriptive analytics, and this is all a must for every single bank, right? Even performing, let's say, advanced prescriptive analytics or so much more, and all these are starting at this age. Banks have started to realize that this will again help you generate very good insights, and this will result in extremely good business impact, and it will help the banks as well. On that note, we need to check out how data analytics is helping in the banking industry as well, right? So it is used to acquire and retain customers, it is used to detect detect fraud, which is again extremely important with respect to banking. It is used to improve risk control, find new sources of growth for the bank, and to optimize all of the product and generate their portfolio models as well. So as soon as we check out the banking sector again with the e-commerce industry, right? So this is a market which is exploding for the last couple of years. I can say even the decade, right? eBay came up, Flipkart came up, Amazon is again taking over everything, Myntra, Nika. Guys, there are so many e-commerce portals today, and to make sure we perform very good analytics on these e-commerce industries is very vital. So how is data analytics used? Again, it is used to improve user experiences, it is used to enhance customer engagement, customize offers and promotions, maintain effective supply chain management, optimize pricing models, minimize the risk of frauds, provide them very good advertisements that pretty much help them pick up products, good recommendation systems where they'll pick up another product after the first product, guys, and so much more. If you've just bought an iPhone, again, you will pretty much be recommended with a couple of cases that the people have bought as soon as they bought another iPhone. So you might be that person, you might like the case and you might pick it up. At the end of it, you have the case to protect your phone. The business just created more money out of it, right? So again, the analytics, the role of analytics in e-commerce industry is extremely vital. Let's say the people in the e-commerce industry have known this for a while, guys. So coming to the analytics in the insurance industry, again here as well, guys, this is basically used to enhance your customer engagement, acquire new customers, retain the existing customers, make sure the customers don't leave, prevent the frauds, at the end of it reduce the frauds, prioritize all the claims that need, because you'll have medical insurance, you'll have again health insurances, you'll have life insurance, you'll have so much more that you need to take, and all of these directly impact the user, right? So making sure you take the feedback from the user, work on it, and then create some analytics out of it is again very vital, guys.
I want all of you to first read the customer churn file, okay? And we'll see that over here in this read.csv, we have another argument called as strings as factors argument, okay? And we'll see that while reading the file itself, if we set this argument to true, what happens, okay? So let's first read the file. So you all would have stored the file in some location in your system, and you could set the working directory as well. Now, if you set the working directory, so we could set the working directory using setlbd function, okay? So setlbd within quotes, you could mention, let's say, wherever the file that you do have. So for example, in my system, the file is in this particular location, okay? Now, if I set this particular working directory, now I could just use getlbd function to see that whether it has been changed or not, what is my current working directory. And to read the file, I could just mention customer_churn. So this is the data frame name where we would like to store our data set. Assignment operator, read.csv, and within quotes, I could directly just mention my file name. Okay, so the name of the file is customer_churn.csv. All right, so now, so you have to mention, let's say, if I do have this particular file in this particular folder itself, I need not to mention the complete path of the file over here in read.csv. Okay, I could directly mention within quotes just the file name along with the extension .csv. In case if my file is not present in this location, so if I don't mention the path, it will check that whether this file is available in this particular working directory. If it is there, it will directly read. If it is not, it will give an error saying that no such file name or directory, incorrect in directory. Okay, so for example, I just mentioned 1, 2 like this. Okay, so it will give error me like no such file or directory. Okay, so you need to check that either the file name is correct or the path is correct or not. Okay, in R, anytime you get error, it will be shown like error colon. Okay, so for example, I just print O and I just hit enter, it will show like error colon the error message. Okay, all right, so let me just read the file by mentioning the correct file name, that is customer_churn.csv. Now over here in the global environment, you could see that our file name is there, right? 7043 observations of 21 variables. So observations means number of rows that we have, and 21 variables means 21 columns. All right, okay. Now a function that could help us to know a couple of important things about this customer churn data frame is str function. Okay, so if we do str of customer churn, it shows a couple of important information to us. Okay, so let's see what str function returns. So we have just right now read the file just by mentioning read.csv, customer_churn.csv. Okay, you need to make sure that you have to use always the / in R. Okay, so by default, in Windows, when you copy paste the path of the folder, it would be by default would be coming as backslash, which you need to change to forward slash. So either you have to use the double backslash or the forward slash. Okay, so please read the file just by mentioning customer churn. So this is the assignment operator. Okay, so we mentioned customer churn. This is the data frame name which we are mentioning. So what is data frame? So data frame is something, if you look into any Excel sheet where you have rows and the columns, right? So in R, we call them as data frame. In Python also, we call that as data frame. So it's just two-dimensional heterogeneous data. That means we could have multiple columns and each column could have different data type. That means I could have a customer name, which could be character. I could have age as a column, which could be integer. I could have number of transactions that they have done in that month. That's it. That could be integer. We could have their gender, which is male or female, which could be a categorical type data. Okay, we could have different data types in different columns, right? That is something which we call it as data frame in R. Okay, so we are reading this, importing this CSV file in this system, in this RStudio using read.csv. Okay, so read.csv within codes, we are mentioning the complete path of the file at first. Okay, so I have stored my file in this particular location, and then the file name, which is customer_churn.csv. Okay, now this is the very first step. I want everyone to be on the same page, because if you're not able to read the file, you won't be able to move forward. Okay, so all the operation that we'll be doing will be on this customer_churn file itself. Okay, now in this customer churn, if we use this function called as str function. Okay, so str over here, it shows the structure of our data frame that we have read. And let's look what this function returns in output. Now, str function first tells that this data set is something which we call this data frame. So data type of this customer churn is data.frame. It has 7,043 observations. That means 7,043 rows, 21 columns. Okay, and it shows all the column names and their respective data types. Now, these are not much important for us to look into. These are just first couple of values that we have in this column. Now, one thing that you observe over here, that all the string variables, they are read as character. Okay, now in R, there's a couple of data types which we talk about, like integer, numeric, character, logical. Another data type that we have specifically in R called as factor. Okay, now there's a difference between character variables and factor variables. Okay, now if you see the variables like customer name, for example. Okay, so if you have 10,000 customers in your data set, 10,000 could have all different names, and that is a kind of character variable. Now, if you have another column like gender, okay, or let's say nationality class, there would be two genders, or let's say in your data set you have nationality of 3 different countries. Okay, so these are certain categories among themselves, right? And something that you could call them as, these are categorical data. And in R, we call them as factor type data. Okay, so another data type in R that we have is factor. Okay, so features like gender, you have male, female, partner over here, yes, dependence, yes. These are categorical variable. Okay, and in R, it's important that we correctly mention the data type of the features. Okay, now, for example, why is it important then? Why can't we just keep them in the character only? Why is it needed to convert to factor, for example, if the question is that? Now, two major reasons. I would say, why is it important right now to convert the data type to the right one? Because, for example, in visualization, in certain cases, for example, you would like to create a bar chart for gender. So bar chart would show how many males are there, how many females are there in two different bars, right? And it won't create the chart for you if gender is not in the factor type. Okay, so it considers that, all right, so for categorical type, we create bar chart, so the column has to be of factor type only. Okay, so it's important for us over here that we rightly mention the data type of the columns. Now, in this data set, actually, all the string variables that we have, these are actually all categorical columns on. Okay, now instead of individually converting the data types from one to another, all this character to factor type data, we can do that job while reading the file itself. Okay, so there's an argument called as strings as factors. Okay, so if you just set the strings as factors is equal to true, so in R you can write true or false like this, capital TRUE in caps or just capital T, both refers to the same thing. Okay, so if you set this strings as factors is equal to true, now let's see what happens over there. Let's check the str function again. You see that all the string variables, they are read as factor. Okay, there's no change in the integer or the numeric columns. All the character variables, the string variables that you had, these are now read as factor. So we need not to right now convert all the character to factor individually. So while reading the file itself, we have mentioned, we have just set this argument is equal to true. We just let all the string variables as read as factor variable only. Okay. Now R is case sensitive language, so you need to make sure that even the argument name, whatever you're mentioning, is correct. So over here, you could see that A and F is in capital. So you need to make sure that you're writing the exact argument name as well. Okay. All right. Now, so I want moving forward, like we would be, almost all the sessions will be talking about this data frame itself. So whenever you would be reading the file, customer churn, so make sure that you run this command, okay, where you write strings as factors is equal to true.
Just a quick info, guys. If you are looking for data analytics course, then we have a good news for you. Intellipaat is providing an advanced certification in data analytics for business with IIT Madras. The course is of very high quality and very cost effective. The course link is given in the description below. Now, let's continue with the session.
So the command that you have earlier executed for read.csv, just add this argument strings as factors is equal to true. Okay, and you could use this command also to check str of customer churn. Now, in today's session for data manipulation, we would be using functions from a very popular package called dply, which we just pronounced them as dply package. Okay, so dply is very, very powerful package for doing any kind of data manipulation task. Okay, so we would be first installing the package and then loading it. So installation of package is just a one-time task. Okay, but installation is not sufficient to use the functions from that package. We need to load the package then to let the system know that, all right, so in this session, we are going to use that particular package. Okay, so you could have like 50, 60 packages installed or in your system, but it's not that in every session you'll be using all of them, right? So it'll be just loading whichever is necessary. So you could install the package using install.packages function, and within quotes, you need to mention the package name. Okay, so for example, in my system, I've already installed, so I need not to reinstall the package. Okay, so you could, so if you have already earlier installed, you need not to execute this command. But if you have not installed it, so please do install the package. Okay, just run this command. It will take even less than a minute to get it installed. So it will come to new command prompt, and then you could run this library command to load it. Okay, so we mentioned library, again the package name, so and just hit enter. Now it might show you certain friendly message like this. Okay, and this is not an error. Okay, don't get scared with looking into the red color. Okay, now in R you might get some warning message, error message, or some friendly message like this. Only if it is error, it's scary and something that you might be bothering about. But this is just a friendly message saying that, right, so we are attaching package dplyr, few functions are masked from different other packages. That's it. Okay, you might get some message like this, or you might directly the command. If you just execute the command, it will go to the new command prompt without showing any message. That also means that you have successfully loaded the package. Okay, so I want all of you to first, if you have read the file, just go ahead with installing the package and load the package using this command. Now, if you don't load this package, moving forward, whatever command that you'd be executing, you won't be able to execute because it will give you an error saying that function not found, because all the functions moving forward which we'll be talking about are from this package dply. Okay, so you all need to load the package at first, and then we could start using the functions from this package. Okay, now let's start off with a very simple task, which is just selecting the columns from our data frame, which we are interested in. Okay, so there could be a lot of times where we read the file, but our point of interest is just let's say 3 or 4 columns. Okay, and there's no point that to have all the columns, data set and make us confused. Why not just take the 4 columns that we need and start working on that? Correct. So how we could just sample the data, or let's say it's just sampling with respect to columns that we're talking, like we just need the 4 columns in our final data. Okay, so well, there are a couple of ways how we could do the same task in R. Okay, from the base package itself, like without installing any additional package, we could just do this task as well. Okay, so before using this deploy package, let's see how using just a base package, how we can do that. Okay, so let me just clean the screen. You could use Control L. Okay, so Control L is the shortcut for cleaning your screen. Okay, well, I'm writing all the commands in the console section because I'm just trying to showcase all these commands to you all. But I would recommend that please write all the commands in your source pane. Okay, so this is the source pane that we are talking about. Why to write in the source pane? Because these are the commands that you could use it for your later reference as well. Okay, so whatever you write in the console, if you close the particular RStudio, you would lose all the commands that you have executed. Okay, so source pane is just like your notepad where you can write any commands and save that for your later reference. Okay, you could execute the commands. So for example, I've kept the cursor in line number 7, or I could select the line also, and you could click run from here, or you could use Control Enter. Okay, so Control Enter will execute directly the commands in the console section. Okay, all right. Now over here, let's say that, for example, from this customer churn file, we would like to subset the first 4 columns. Okay, now how we could see the column names of our data frame? So in the customer churn, we know that 21 columns are there. We have seen str function could also show us all the column names and their data types. But if our objective is just to see column names, okay, now we have very simple function in R to do that job. So there's a function called as names. So names of your data frame will show us all the column names. Well, okay, I could also use call names function. Call names of customer churn will also return the very same output. Okay, there's no difference between the 2 functions, names and call names. You could use whichever you're comfortable to remember. Okay, so call names, I believe, would be easier also. So call names, because it's written call means columns. Okay, so it returned all the column names to us. Okay, and let's say our objective is to create, let's say, another data frame where we would like to keep just the first 4 columns: customer ID, gender, senior citizen, and partner. Okay, and we would like to store that in a data frame called as df. So we write df. This is our assignment operator, less than sign, minus. We write the customer churn. Now to subset the data frame in the base package, we use double quotes, right? And over here we have rows and we have columns, right? So to separate them out, we use a comma over here. Okay, so before the comma, it means for rows. After the comma is for columns. Okay, so how do we mention that we like to select these 4 columns? Now, if you keep blank before the comma, it means all the rows you are selecting. And after the comma, you could mention the column numbers or the column names that you would like to select. Okay, so over here, if you like to mention just the first 4 columns, we could mention 1:4, right? So 1:4 means the first 4 columns. Okay, so let me just show you. 1:4 means it creates a sequence of numbers, right? 1, 2, 3, 4. We could have also used the C function. So C function is just a command. You can't just give the numbers 1, 2, 3, 4 in R. So you have to use the C function, right? So we can't just save something like D1, 2, 3, 4. Okay, so it will give you an error. So to combine these values together, we have to use a function called as C function. Okay, so C function in R, there's no other full form. You can think of it as a combine or concatenate. Okay, so they will have just the values 1, 2, 3, 4. So either you could write like this, or you could just mention 1:4, which means it's a sequence of numbers from 1 to 4. Now let's run this command. So df over here, so we are just skipping all the rows. So before the comma, we kept it blank. And after the comma, we mentioned 1:4. That means we are subsetting the first 4 columns into df data frame. So if I just use call names of df, you'll see that only the first 4 columns are selected. Okay, so I could use the dim function to see. So if you see, all the rows have been selected and only the first 4 columns. Okay, now over here, if you see in the base package, to do this particular task, you have to remember this particular syntax although. Okay, so which is at the very first stage while you learn, it might look complicated, although over the period of time you would feel comfortable with this. Well, even a simpler way of doing this task using the dplyr package. Okay, and the function to do this task, like selecting columns. So in the end, what we are trying to do over here, the objective was to select all the rows. There's whatever rows are there, that's fine. But our objective is just to select the first 4 columns, right? Or let's say customer ID, gender, senior citizen, part. These 4 columns we needed, right? So in dplyr, there's a package called as, there's a function called as select function. So the name is also pretty simple. Select is for selecting columns. Okay. Now all the dplyr functions, okay, whatever we would be discussing in today's session, they all follow very similar syntax. And what is it? So the output of any dplyr function is a data frame. Okay. We use the function, for example, select, okay, for selecting the columns. So let's start. So df is the data frame. The output, we are using the select function. The first argument of any dplyr function is the data frame name, okay, on which we'll do this manipulation. So we are just mentioning customer churn, and the subsequent arguments would be based on the function whatever we are using. Like select function is for selecting columns, so we'll just mention the column names or column numbers. So you can mention the column numbers like column index, so like 1:4, or you can write the column names also. All right, so you could mention something like this 1:4. So it means you're selecting the first 4 columns. Okay, so it's as simple as that. You could see the syntax now. Select data frame name and just the column numbers. So how about if it's not sequence of numbers? I could also mention like 1, 2, 5, 10, 21. That's also fine. So you can see how simple it is. Like you need not to use C function, anything. Okay. All right. So select function is like select data frame name and just the column number, or you could mention the column names as well. Like instead of writing column numbers, you could mention like customer ID, comma, gender, comma, partner. Okay. That's it. So I'm selecting, let's say, these 3 columns, customer ID, gender, and partner. Okay. While writing column names, we are not using, if you see any C function, codes, nothing. Okay? Just the column names. Okay. So if you see the call names of df, you see we have selected customer ID, gender, and partner. Okay. So over here in this script, so we're starting from here. So this is something different of it. So from line number 57. So just mention over here that the first argument is the data frame. The subsequent arguments what to do with the data frame using the variables, and the result is also a data frame. So over here, if you see select data frame name, so I've mentioned 2 or 6 or any column numbers. So whatever column indexes that you would like to mention, you could use that and just storing into some new data frame. So we are not changing anything to our customer trend file. That's why we are just storing into some new data frames. Okay, so these are the data frames which the output would generate. You could also mention the column names as well, like gender, just gender column will be selected, gender, partner, tenure. That means these 3 columns would be getting selected. What it means by gender colon contract, this just means that it will select all the columns from gender till contract. So if I just open see gender colon contract, you could see it has selected all the columns from gender till contract. Okay, so if you see the syntax of this dplyr is pretty much simpler than even the base package that we have done. Okay, so once you execute each of these commands, okay, so for example, you are creating C_2, C_6, C_bunch. Okay, these are like all the data frame names, correct? So use the select function, data frame name, the column numbers or column name, assignment operator, and the output will be a data frame. So once you create, let's say C_2, just use dim of C_2 and call names. So this will give you a clear idea. Okay, so what exactly happened once we're executing this command. Okay, so over here, so one more addition on top of this. Okay, so this is additional functions which are part of base package only, and it's not like something to be used only with select function. It could be used anywhere, okay, in other commands as well, but these are very useful functions. Now something we are just leveraging this function in our select as well. Okay, So it's like starts with stream, for example. Okay, well, in this particular example, in this use case, in our scenario using customer journey, it's not much meaningful. But let me give a scenario like where these functions could be very useful. Okay, so imagine that you have a data set, let's say transactional data. You have the information of January, February, and March. Okay, and these are all in the column names where you have the data like Jan underscore number of transaction, Jan underscore transaction amount, Jan underscore number of logons, like this. Okay. Similarly for Feb underscore transaction amount, Feb underscore logons. Similarly for March, like March underscore number of transaction, like this. And you have to select, let's say, all the Jan information. So instead of writing all the column names like Jan underscore transaction amount, or Jan underscore logons, like this, you could just mention like select all the columns like which starts with Jan, right? Or it ends with Jan. All right, it contains a specific string. So that you could mention like this, starts with a particular string or ends with a particular string or contains a particular string. Okay, so this additional stuff for which I would like to mention in this case, because there could be certain scenarios where this could be very, very useful. Instead of writing 7-8 column names, you could just mention the function and use the particular string to subset your columns. Okay, all right, so just execute this commands as well. And you could look into the column names as well, like what is the output of this system, like what column names that we got over here. So if I just use this, so you see that it's like a string TV stream, it's like starts with the string, right? So let's now talk about have a scenario where you like to subset the data set while giving certain criteria. Okay, now for example, you might be willing to select.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following is a false statement about data analytics? A. It collects data. B. It looks for patterns. C. It does not organize data. D. It analyzes data. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's say let's consider our data set customer churn. We have gender column. Let's say we would like to consider all the male customers and whose tenure is, let's say, greater than 5 months. Okay, so they have been into the platform for at least 5 months. Okay, so two conditions: gender is equal to male and tenure should be greater than 5. Okay, how we could do that? All right, so let's first just do one. Let's say I would like to just subset the male customers. Now let me just clean the screen, Control L. Cool. So we have a function called as filter function. Okay, so I'll just store again in something called as df1. Okay, so we'll use this filter function. So filter function is something that we're going to use now to subset the data frame based on criteria. Okay, certain conditions. So what will be the first argument over here? So the first argument of any deploy function would be our data frame, right? So that is our customer churn. And the subsequent argument over here would be the conditions, right? So over here, we would like to see just the male customer, right? So what we'll be doing is we'll be just writing comma gender equal to within quotes, just mention it male. Okay, so over here male is one category, right? And to mention this, we have to mention within quotes, and equal to operation in R we use double equal to. So be it in R or Python, because equality is just used for assignment operator also. So equality, when you'd like to check whether the gender is equal to male, so we have to use double equal to. Okay, so gender equal to male. So df1 will have all the male customers. If I just open df1, that would have all the male customers. Now there's a very, very useful function in this package itself called as table function. So table function could help us. Typically we use it for categorical columns only. So what it tells us that, let's say you use customer churn $, so the column name we would like to check it for gender. So in the base package, if you like to select a column, we use the $sign, right? So customer churn $, it will show you all the columns. You could select gender. So table function returns that, for example, gender $sign is for selecting the columns. Okay, so to select any column from a data frame, you have to use $sign. Okay, so you mentioned column name. Now table function returns that how many number of observations you have under each of these categories. So gender is a categorical column, right? And it has two categories, male and female. So how many observations you have under male and how many observations you have under female. table function would return that. Okay, so now you could also use, so saying that, so typically if you see whatever categorical column you mentioned, typically it will show you for each category how many number of observations you have, right? You could also use this for numeric column, saying any condition. So for example, I could mention tenure greater than 5. Okay, it will show you now greater than 5 means I'm giving a condition like this should be greater than 5. Like it will have two things like true and false. True means 5672 customers, they have tenure greater than 5. 1371 less than equal to 5. Okay, so you can give some condition for numeric columns also. All right, now typically if you use for any category column, it will show you for each category how many observations you have. So if you see, we have selected gender equal to male, right? If I use dim of df1, it showed me 3,555 rows and 21 columns, right? And that's exactly, if you see the number is right, so we have 3,555 male, and that's what it has selected, right? So that means it's just a kind of cross check also that, all right, so whatever filter function we have used, it correctly subset all the male customers. Okay, all right, now the initial question that we had was to select male customers and tenure greater than 5. How we are going to do that? We could add now over here and operator. So ampersand, this is and operator, and tenure greater than 5. Well, if you see, now there could be one question. If you see, to access the columns, we just talked that we have to use dollar. Then why we are not keeping dollar over here? Why we are not writing customer churn dollar gender equal to male and customer churn dollar tenure greater than 5? Well, this is an exception for any deployed function. When you're using deployed functions like select, filter, you could directly access the column names because we are referring customer churn. So any column name, whatever you're mentioning, it will understand that gender is a column name of customer churn. Okay, so you need not to use dollar. So that's the kind of simplicity of using deployed function. Okay, but if you're using just a base package, anytime, any function to access the column, you have to use dollars. Okay, all right. So this is the syntax. So in df1 right now, I'll be having, so if I use now dim of df1, you see that it has been reduced. Why? Because we have added one more criteria that it should be male and their tenure should be greater than 5. Okay, so over here we have 285. Okay, so you could have well also use table function for this. Okay, so I could have used like table function. Well, if you're using table function, you have to use like this customer churn. It's from base package, right? So you have to use $sign male. Okay, and again customer churn dollar tenure greater than 5. Okay, now if you see, I've given in table function both the commands. It's showing 285 true cases. That means this is again correct, the df1. Okay, so Brijesh, we just talked, right? Dollar is for accessing the column. To access the column, you have to use $sign. The AND operator that we have used in filter function, we have used this AND operator, right? If we just write this command, okay, instead of AND operator, I just mentioned comma. Okay, so I've just separated the two criteria using a comma. This will also work and will give the same output. Okay, you see, it also gives the same output. So in this filter function, if you separate multiple criteria using comma, it will consider as an AND operator. Okay, so either, so both of this command will return the same output, whether you use using AND operator or using comma. So you could execute the commands from line number 76 to 80. So over here, these two commands are having single criteria like gender female, monthly charges greater than 100, and over here 79, 80 both will return the same output where we are selecting two conditions, gender female and monthly charges greater than 100. Okay, so over here, like we mentioned, streaming TV equal to yes, streaming movie equal to yes, few conditions like tenure greater than 50, internet services DSL, contract is 1 year. Okay, now how about OR operator? So you have this, the pipes in which we call as OR operator just above your enter. All right, so you have this OR operator, and over here we're mentioning payment method electronic check or payment method mailed check. Now scenarios like this, okay, so where for example you have a single column and you have multiple categories, okay, and you'd like to select for example in this like contract 1 year or 2 year. Okay, now scenarios like this where in this case, let's say you like to select two categories, so 1 year or contract 2 year. There could be scenarios like you have, let's say 6-7 categories, and out of that you like to select 4 of them. Okay, out of 7 you like to select 4 of them. Now you could use this method like let's say the column name is CUL, okay, and the categories like cat 1, cat 2, cat 3 till cat 7. Now you'd like to select first cats like cat 1, cat 2, cat 3, and cat 4, right? So you would be mentioning like call equal to cat 1, or call equal to cat 2, or cat equal to cat 3, or call equal to cat 4, right? Now instead of saying like this, okay, which is something tiresome and something very big, right? You could use something called as in operator. Okay, so in operator is something which looks like this: percent in percent. Okay, so you could mention something like this: filter, data frame name, contract in 1 year, comma 2 year. Now we just can't write 1 year, comma 2 year like this. You have to use the C function in this case, okay, to combine these two categories together. Okay, so now the same thing if you wanted to do in the base package. So we could have done like customer churn within the square brackets, because contract is a base package, right? We are not using any function, deploy functions. So you have to use the contract using $sign, customer churn, $contract in 1 year, comma 2 year. And after comma, we are keeping blank because we want to select all the columns and this contract only in 1 year and 2 years. All right, so over here, this could be quite useful in scenarios like where we'd like to select multiple categories. So in that scenario, the example that we're just talking about, we could have mentioned like call in C function, cat 1, comma cat 2, comma cat 3, comma cat 4. Okay, so which is much simpler and easier to write rather than writing or operator 4 times, right? And if you like to mention like not in, okay, so like contract not in 1 year, 2 year. So you don't have anything kind of NOTIN, rather you could use the not operator like this: explanatory, contract in 1 year, comma 2 year. That means like contract not in 1 year or 2 year. Okay, all right, well, in our any missing values, okay, so if you have any missing values in your data, it will be shown as NA, okay, in capital NA. So it means that it's missing value, okay, you don't have any data, and these are read in R as NA. Okay, and these are important part of our analysis to understand that how many missing values we have in our data set, and if we have any missing value, in which columns we do have, right? I could have, let's say, 50 missing values, and it need not to be that all 50 are in a single column, right? I could have 50 out of 50, 25 in one column and another 25 in another column, right? So to know that how many missing values we have now, so let's just give me a simple example. So I'm creating a vector v with some values. Now this vector v has 5 values, out of which 2 are missing. Okay, so this I'm just creating a vector, a kind of a set of values, so which we're combining using the C function, in which we have 2 missing values. Okay, now there's a function called as is.na function. Okay, is.na of the vector name, when you mention it, returns an output as true or false. Okay, is dot functions typically always return true, false output. Okay, so if you see these 2 missing values that we have in the third and the fourth position, it showed 2 over here. Now over here is just 5 values we have, right? And easy that we could just count 2 missing values up there. How about in our data set? We have 7,500, right? We can't just use this dot and count like wherever we have 2 cases, right? So what we could do is we could just add them, right? So sum of is.na of v, if we do, it will just tell me that there are 2 missing values, and that is exactly which we want in this customer churn, right? So if we want to know how many missing values we have in this customer churn data set, we could use sum of is.na of customer churn. So it returned 11. That means in this data frame we have 11 missing values, and the next task becomes that to know in which columns. Now if you like to see in individual column wise, we could use like dollar, then column name, again dollar, column name. Now individual column wise we could do like this, but we won't be willing to 21 times, right? If I would like to see then in which column I do have this 11 missing value. So instead of doing all the stuff, there's another function called as call sums. So call sums does column wise summation. So if I do call sums of is.na of customer churn, it will return me in each column wise how many missing values we have. And if you see, it's 0 for all of them except total charges. So we have like all the 11 missing values in total charges itself. Okay, and there's something, let's say if I like to just subset which are these rows where we have missing values in total charges, I could also use this filter function to do that. Filter customer churn, comma, is dot any of total charges. Okay, so what it will do, so it created any underscore df where you have this 11 rows wherever you have missing values in total charges. You see, it's just written as n. Okay, well, this piece of code is very important. So I want of you to just run this command like sum of is dot n of customer churn. Please keep a note of this also. Well, in R, if you'd like to write any comments, okay, you could use hashtag, okay, like this. So hashtag, anything you write that won't be executed in your console section. Okay, you could the shortcut for, so if you like to, let's say, comment out multiple lines, so let's say I would like to comment out these 2 lines, so shortcut is Control Shift C. Again, if you like to uncomment, you could use Control Shift C. Okay, so these are kind of few useful shortcuts. Okay, so if you just do Control+1, well, if I'm right now I'm in console section, if I just use Control+1, it will take me to the source pane. If I do Control+2, it will take me to the console pane. Control+L to clean my console screen. If I like to comment out multiple commands, I could just select them, use Control+Shift+C, okay, which is important one. And to execute any command from my source pane, we could use Control+Enter. Okay, all right. So next, let's see how we could add new columns to our data frame. Okay, so adding new columns is like more of either you could give some static value. So for example, you have a data set and you like to mention that, all right, so these are all from the month of December. Okay, you could mention, let's say, a new column name equal to December. So all the rows will have the same value month as December. You could have logic like you could like to create a sequence of numbers from 1 to total number of rows that you have. Okay, that will become a kind of unique values for each and every row, which is nothing but a sequence of numbers. You could have some logic like using if else, like if this is yes, make it as a 1, if it is false, make it as a 0. Okay, you could make some new variable like based on certain business logic. Okay, so for example, in this case, we'd like to create something over here as an example. So to add any new column in our existing data frame, we could use the mutate function. Okay, so let's try to see how we could do that. So we're using mutate function over here to create a new column called as customer underscore category. Okay, so this is the new column name. So we mentioned, and if you see, we are storing back in the same original data frame customer churn. That means a new column called as customer underscore category will be creating in the end of this data frame customer churn. Mutate function, the first argument will always be data frame name. Next, this is the new column name equal to its logic. So to create this logic, we're using if else function. So the business logic, for example, the business has told us, the business team that, all right, so I'd like to create a column customer category where if the monthly charges is less than 45, call them as low paying customer. If it is between 45 to 90, call them medium paying. If they're greater than equal to 90, or whether greater than equal to 90, call them high paying. Okay, so like 3 categories they would like to create. Okay, and that is something we could do using if else function. Now let's see how we could do a simple task using if else function in R. Okay, so for example, in our data set, in our customer churn, so over here we have a column called as churn column. Okay, where we have 2 categories, no and yes. Okay, so if I just do table function, so table customer churn dollar churn, we have 2 categories, yes and no. 1869 got churn and the remaining they didn't get churn. So churn means the current the company and they have joined with someone else. All right, so it's more of like telecom company data set, right? So it's like they used to have some provider that they used to follow, and then something they left this particular one and picked up someone else. So over here, our objectives, let's say very simple, like we'd like to create a new column where we'll mark yes as 1 and no as 0. Okay, now we could create a new column using base package as well, okay, without using mutate function also. How we could do that? Let's see that first. So we mentioned customer churn, a new column name, which I'm naming it as new underscore call, or let's say new underscore churn assignment operator. So this is the new column name that we are providing. Okay, and now we are using if else function. Now the syntax of if else is very simple. Okay, so if you see over here, it's showing also to us that test comma yes comma no. Well, anytime you feel that you forgot what was the syntax of if else, don't worry, you can always do question mark if else and see over here what the syntax looks like. Okay, so you could see over here if else argument name and their definition as well. Okay, it's quite simple over here. Let's see what is if else function over here. First is test, like the condition that we'd like to check. So what is the condition? We would like to just say that if it is yes, customer churn equal to yes, what we're going to do over here. If it is true, that means if it is yes, we want to mark them as 1. Okay, so we just write 1. The third argument is if it is false, what we're going to do. That means if it is no, we'll mark them as 0. It's as simple as that. So we just created a new column, okay, named as new underscore churn. If you see, so it's just we mark yes as 1, no as 0. Okay, so you can see over here, new column has been created. So wherever we have yes, they're marked as 1. Wherever it's no, it's marked as 0. So is this syntax clear to everyone? The ifelse. Very simple syntax, but very useful one. So over here, the advantage of muted function is that just now, as we have seen, like using base package, we have just created one new column called as new underscore churn, right? Using ifelse. Now, if you see, we could just create one column at a time, right? But if you use muted function, you could create multiple new columns in a single using a single muted function itself. Like in this case, as I'm creating 2 columns, ID, ID2. So in this, you have 7,043 rows, right? So I'm creating a sequence of numbers, like 1 to total number of rows we have. So total number of rows. So DIM function, you have seen customer churn. It shows rows and columns, right? If you want to see only number of rows, you could use nrow function. If you like to see only number of columns, you could use ncol function. So nrow function number of rows, ncol number shows number of columns. And the DIM function tells you both of them, number of rows and then number of columns. Okay, so this is something we are doing 1 colon number of rows of customer churn, that is 7,043. Okay, and a static value of 2 in ID2. Okay, so it will create a new 2 new columns, ID and ID2. Okay, so in base package, if you had to create, you could create just one at a time, like customer churn dollar and ID3, 1 colon nrow of customer churn. So nrow of customer churn means number of rows, right? So that means nothing but 1 colon 7,043. So it will create a sequence of numbers. Okay, so in your customer churn, if you say, so ID3 is just like ID, a sequence of numbers. Okay, so this is something which we just did, like churn underscore new column name, ifelse. If it is churn is yes, 1, otherwise 0. So this two are using like base package, like where we are using dollar and the new column name. And in dplyr, we are using at first the muted function, data frame name, and then new column name and whatever logic we'd like to use. And we could create multiple new columns as well. All right. So these are the commands for the muted function. And this is again quite useful because there could be a lot of scenarios where we might be interested to create new columns. Okay. And to do that, muted is a very cool and simple way to add multiple new columns just using a single command itself. Now, there's another function which is a part of dplyr itself called a summarize function. Okay, now the summarize means it will just create some aggregated function for you. Now, if you see, just doing some aggregation on the whole data using summarize is not much useful. Okay, so just the commands like this 136 to 138 that we have over here, we are mentioning data frame name and just a name of the result as mean underscore tenure. We are using some aggregate function like mean of tenure, mean of monthly charges. Okay, now this is not much useful. Why? Because we could have just done this simple mean of tenure. So we could have written mean of customer churn dollar tenure, right? So that's the same result, 32.37115. If we wanted to round it off, we could just use round mean of this comma 2. That means round to 2 digits, 32.37. Now, summarize function just like this is not much useful. As you could see that we could have simply just written just the function, right? Summarize function, although, becomes very useful when we would like to use it along with group by function, which we'll see next. Well, why it's needed, we'll come into that one. But before that, we could see over here, there's something called as na.rm is equal to s dimension. So let's talk about that first. So before taking the break, we have seen that how to find the missing values, right? So if you recall, we have seen that in total charges, there are 11 missing values, right? So sum of is.na, customer churn, dollar, total charges, there are 11 missing values. Okay. Now, any mathematical function. So for example, I would like to calculate mean of total charges. Okay. It will give me n. I would like to do sum. that would also show us that any mathematical function, if you do on a column that has missing value, it would return NA. Okay, so a simple way of handling this scenario is like, to get the result, you could add this argument. You could set this na.rm is equal to true. What does this na.rm refers to? What it will do is it will exclude this 11 missing values that you have in total charges and will calculate with the remaining ones. Now, it's not removing the missing value from your data. Okay, so if I do this, what it did, it just excluded the 11 values and will calculate the mean with the remaining values that you have. So if I do this sum of is.na of customer churn dollar total charges, I still do have the 11 missing values. But for the calculation purpose, it just excluded them for the result, because otherwise it will give me NA on. Okay, this is very important point to keep a note of. So anytime you do any mathematical operation and you get NA as a result, the first thing you should check is whether you do have any missing value in that column. If you do have, just mention NA.rm solution. Okay. All right. So now, for example, you did calculate the average of monthly charges or tenure by just mentioning, let's say, mean of customer churn $10, right? So this is for all the customers. So we had 7,040 customers, and altogether we are calculating for them. But their behavior might be different for different type of customers, right? You might be willing to group by intent service, or for example, you'd like to group it by the customers who got churn. So for each category, you would like to see what is the average tenure of them. Okay, so you could do something like this: summarize. Okay, so inside summarize, you could use the group by function. Okay, so group by, you mentioned the first argument as data frame name, comma. So you like to group it by churn column. Okay, and then you like to calculate, let's say, the mean, let's say average tenure is the name of the column name you like to give. Average tenure equal to mean of tenure. Okay, now, all right, so let's save that into a data frame. Okay, so I'll just save that into a data frame called as df2. Now, if I just open df2 over here, okay, so over here it showed me that it grouped by churn. That means churn who got churn, their average tenure, who didn't get churn, average tenure. So you see, the behavior is quite different, right? It's 18 for them and it's 38 for them, right? So you could just use the round function as well. So round of mean of tenure. So if you see, it's 18 months for customers who got churn, and average tenure is 38 months for who didn't get churn, right? So this become quite useful in deep dive analysis, where you like to group it by some category and then you aggregate them. And this is a very useful one. Now, the syntax might look a bit difficult in the very first go, but I would say typically we don't use this syntax because we have a simpler way of doing the very same task. With the same function, group by and summarize, we'll see in some time another simpler way of doing the very same job. Okay, so these commands that we have, this line number 145 to 147, okay, where we are grouping by certain categorical columns and doing some aggregated metrics. The same thing could be done using a very simpler syntax, okay, which we'll just look in some time. So before that, just I would like to talk about one simple function called as arrange function. Okay, now arrange function is something, again, a very simple and needed one. It's like just sort the data, right? So you like to sort it in the ascending order based out of a particular column, or in the descending order. So arrange function could do that particular job for us, which is from, again, deep dive package. The first argument is data frame name, and then, so for example, I would like to arrange in the monthly order, monthly charges ascending order. Okay, so this syntax will do that. Okay, so arrange customer churn monthly charges. So what it will do is, so if I just look into this particular data frame called as new, so the whole data frame has been rearranged in the ascending order of monthly charges. Okay, so you could see that it has been arranged in the ascending order of monthly charges. Now, if you just mention DESC over here, this becomes in the descending order. Okay, so now if you see new, it has been rearranged in the descending order based on the descending order of monthly charges. So This is a very useful one where, again, many times you might be interested to just rearrange the data with respect to ascending order of a column or in the descending order. Even you could add multiple columns, like after monthly charges, rearrange with respect to tenure, let's say. So you could mention like customer churn monthly charges, comma, tenure. Okay, so it will first arrange in the ascending order of monthly charges, then with respect to tenure. Okay, that also could be. All right. So a simple function, but again, quite useful one many times. Okay, but I would say while executing this, don't bother much about this particular summarize group by syntax, because we'll just next talk about a simpler way of doing this. Okay, all right. So till now, all the commands that we have discussed so far, okay, these are something that you could just use them individually, right? So for example, you could select columns using select function. You could give some criteria to the columns using filter function. You could use muted to add new columns. You could use arrange functions to sort the data. But how about if you like to do multiple stuff together? Let's say you would like to select all the mail customers and then arrange the data with respect to tenure of the customers in the, or let's say in the descending order of tenure. Okay, so you know that, all right, so first I have to use filter function and then I will use arrange function. So it's like two different commands you're executing, right? Now,
Just a quick info, guys. If you are looking for data analytics course, then we have a good news for you. Intellipaat is providing an advanced certification in data analytics for business with IIT Madras. The course is of very high quality and very cost effective. The course link is given in the description below. Now, let's continue with the session.
we could actually do this task using a single command as well. Okay, and to do that, we have something called as pipe operator. Okay, so let's see that how it works. So I'm creating again just the same simple data frame name as df. Now the syntax is we first mention the data frame, okay, and then we use something that we're calling as pipe operator, which is nothing but percent greater than sign percent. Okay, and then we mention the column, I mean the function. So let's say we like to filter mail customer. Now, if you see over here, I've not mentioned the first argument as data frame name. Why? Because the syntax is like we have already mentioned customer churn. So whatever function we'll be using, it will meant for only customer churn only.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following method creates a new array object that looks at the same data? A. View. B. Copy. C. Paste. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so gender, it's expecting that it's a column from your customer churn data. Okay, so I'm directly writing the criteria that I do have. And then the next task wanted to do is arrange the data frame in the descending order of tenure. That's it. So in DF, if you see, right now I do have only the mail customers and the tenure in the descending order, correct? So instead of writing two different commands, I've done the task in just a single function, in a single command. Okay, so now that we have understood the pipe operator, now we can think of doing the same group by task using this, right? Let's do that. So let me create df1 customer churn. We wanted to group it by churn column, right? So let's use pipe operator. First task is group by. So group by churn, and then again pipe operator. Now we would like to summarize. Let's say average tenure is equal to, okay, we'll round off mean of tenure. Okay, that's it. So let's look into df1. So we have this result. Now you could see the syntax. How simple is it, right? So customer churn, group by churn, and then just summarize your writing, right? So it's much simpler than the command that we have just seen a few minutes back, right? So, and it's sequential, right? We just mentioned the data frame name. We are grouping it by churn, and then we are aggregating this. And if you see, we can, the advantage of this syntax is that you could have multiple aggregation. Like I've used average tenure, then you can use, let's say, average charges is equal to mean of monthly charges, let's say. Okay, so it just added average monthly charges also. Okay, so if you like to see how many customers we have under each category, okay, so for that we have a function called as n function. Okay, so like I'm just naming it as cust equal to, so this is a function called as n function. Okay, so n function will give you the number of customers we have. Okay, so this is very similar to like your table function that we have seen, customer churn, dollar churn. It tells us how many observations we have on each category, right? That's what this also is doing. So for each category of churn, how many observations we have. Okay, so you can see multiple aggregated metrics we are able to do using this syntax. So this pipe operator becomes very useful when you like to do multiple deploy functions together. Like when you know that, all right, so I have to select these columns and then I have to group it by this column, and then I have to calculate the aggregated metric of this column. Just use this pipe operator. Use pipe operator, select pipe operator, group by pipe operator, summarize function. Okay.
So while doing any data exploration, once we create our data set, we could do certain analysis by doing some group by looking at the data. And many times it gives us a good understanding of the data many times just by doing some quick visualization as well, right? So as a part of exploratory analysis, again, doing some data visualization helps us to understand more about the data. And next, if you think about once you complete the project or once you are done with your analysis, typically the best way to showcase those data is to visualize them, right? So if you like to present your solution to your business stakeholders or your tech managers, the best way that you could do that, if you could just simplify the whole data by visualizing them, right? And R is a great language to do such kind of data visualization. Okay, so we have a great package called as ggplot2 package for doing amazing visualization, which could be used for directly for any presentations or paper publications or any business presentations. Okay, so well, just like for data manipulation, you've seen that certain tasks could be done using base package as well as using deploy, right? So for example, if you would like to subset based on a certain criteria or select certain columns, you could do that using base package just by using square brackets and mention the condition, comma, blank, or the column names, or you could use deploy select function or the filter function, correct? So the same way in data visualization as well in R, you could use the base functions to create charts, but they do have certain limitations. Okay, so we don't have full power to create some amazing visualization using base package. Okay, so and because of certain limitations that we have in the base package, we typically try to prefer to go for the ggplot. Now, base package functions, this could be good for just a quick visualization for yourself. But if you talk about for creating the charts for certain presentations, I would definitely recommend ggplot. Okay, so now ggplot commands might look a bit lengthy or again kind of big code, but if you just try to understand the syntax, it's pretty simple and pretty useful. Okay, all right, so the first thing, you have to install the package. So you could use install.packages within quotes, mention the package name. So installation is just one-time task. If you have already earlier installed, you need not to install it. So you could directly run that library command. Okay, so I want everyone to just load both the packages, ggplot2 and dplwire. Okay, and well, these messages are not an error message. Okay, this is just a friendly message which you could ignore. Okay, and read the customer churn file. Make sure everyone you read the data by mentioning strings as factors is equal to true. Okay, all right, so just read the file and load this to packages, and please do let me know. So over here, this is commented. Okay, so uncomment this and execute the command at first. And one more thing, again, I would reiterating that make sure that you're referring strings as factors equal to true while reading the file itself. Okay, all right, great. Now the first thing that what we'll be trying to do is we would be willing to create some bar chart. Okay, now the question comes that what exactly is bar chart, or when should we go for this bar chart? Now if we just look into this customer churn data set, there are certain columns like gender, let's say male female, two categories. We have like payment method, electronic check, mail check, bank transfer, paperless billing, yes, no, contract month to month, 1 year, or no contract, right? We have churn column, yes and no, right? So these are the columns which are, if you see, categorical, right? So these are like factor type data. So could you also tell me that which function that we'd be using to check the data type of a column? So if I'd like to know what is the data type of the column churn. So can you tell me the command for this? All right, so str function, yes, you could use, but it shows for all the columns, right? Let's say the objective is just to see only for churn. So for that, you don't need to use the str function. Yep, Sesha, so class function is something directly you could use. So class customer churn, $churn. All right, so if you don't install the package, you would get the error like there's no package called ggplot2. Okay, so make sure that you run this command at first. Okay, all right. So well, one more thing I just would like to mention that, for example, in the chat box, for example, I'm explaining something and someone asks a question. Well, it's not like, all right, cool. So table function would just help you to know that how many customers got churn and how many did. Okay, so within each categories, it will let you know the number of observations under each category that you have. Okay, to check the data. Yep. So one thing, if you're getting class of customer churn, $churn is equal to character, that's because you have not loaded the data set with strings as fact is equal to true. Okay, so that's what I was mentioning, that if you mention strings as fact is equal to true, you would get all the string variables as factored. Okay, so that's what I was repeating this couple of times, that make sure that while you read the file in this data set, mark strings as factors is equal to true. Okay, all right. So over here, if you see, this is a table that we have, right? How many yes and how many no, how many customers got churn and how many didn't get churn, right? And the same table is something that we would like to visualize, right? And this is something which we call it as the bar chart, right? So for any categorical variable, it's a univariate analysis that we're doing, right? How many yes, how many no's are there? And we just want to visualize this. So you need not to copy. I think if you just click on the link, you should be able to open this. All right. So just to visualize using the base package. So at first we'll see a few visualizations how we could do using base package, and then we'll move on to the main ggplot concepts. Okay. So let's first see how we could visualize using base package. So it's pretty simple. Just use plot function. You could use customer churn, let's say churn. Okay. So it will give us this particular visualization. I could just click on plus and zoom it out, where I could see that, all right, so how many yes and how many no's are there, okay, for each category. All right, so I could see for, let's say, plot customer churn $dependence. So dependence is in another categorical column. Now, for example, in this visualization, let's say if you look for dependence column, okay, now let's check the table function, customer churn $dependence. We have around 4933 no to 110. Now, if we just visualize this, our y limit, the y-axis limit is just there till 4,000, right? And something again, our actual data is greater than what's showing in the limits. Something not a good way to visualize like this, right? So you do have some kind of limitations that we do have just by using base package. Now, it's also not like we can't make it better. It's just in that scenario, it just becomes again a big command in that scenario because you need to use a lot of arguments. Now we have the volume argument also, which we'll use to check that how we could change this particular y limits that we have. By default, it might not be the right one, okay, but we could set the limits as well. Now, before setting the limit, now we could change the color of these bars. Okay, so these are default silver colors that you can see. Now, in any visualizations in R, or rather even including Python, so you can directly click the links from your chat window. So over here, so in this link, you have a lot of color codes with all the colors. So you could use any of these color codes. All right. So for example, we have purple 4, purple 3, purple 2, purple 1, purple. Okay. So this like 5 sets of all purple colors. Now, this is something, any of these color codes you could use in your base package R codes or ggplot or even in Python scripts. Okay, in Python visualizations, anywhere you do. So in this plot function, if I just use the argument called as COL, okay, so COL and I just use still blue 4. Okay, now that would just change the color of my bars over here. Okay, okay. C is in capital, I believe. Okay, check the column name as well. And next, if it is a character, it won't work. So make sure it is a factor. Okay, so you can do that by reading the file as strings as factors is equal to true. Okay, so if it's factor, it would work. Okay, so and just check the column name also. It's churn. If you see, it's in capital letter. Okay, all right, cool. So over here, next thing is few traditional changes that we would like to do is like we need to have some x-axis name, y-axis name, the title of the plot, right? So of this, we could do that using simply by mentioning a couple of arguments. So there's an argument called as xlab, which is for x-axis name. So within the quotes, mention any name that you wish to give. So over here, better like whatever the column name it is, we just mention dependence. Ylab for y-axis name. So you mention ylab within quotes, mention let's say frequency, and then we could mention the title of the plot using main argument. Okay, so main argument where you give the title of the chart. So which you can just mention, let's say dependence distribution. Now this looks much better now, where we do have title of the plot, y-axis name, x-axis name. Still one issue right now. Still we do have like the limits not looking correctly. What we could do is we could add the argument called as ylim, where we could mention, let's say from 0 to 5,000. So because 4933 we have, so we could just make 5,000 over here, and that would change my y limit as well. Okay, and this just makes our chart better than what we had in the default, right? And now if you see, we really had to use so many arguments just to create a simple chart, right? And something of this wouldn't have been necessary also if we had a lot of information by default in the chart only, right? Well, something which we see that how ggplot could make our life easier and simpler. Okay, but for now, let's try to understand all these base package visualization commands also. Okay, all right. So plot function, simply the first, if you just mention the any categorical column name, it will show you the number of observations you have under each categories, which we are calling it as a bar chart. Y-axis by default would be the frequency, the values which you could see using the table function, the same thing we are visualizing over here. COL argument is used for giving the color code into the bars. Xlab, ylab is for x-axis and y-axis name. Main is for title of the plot. Ylim we have used to change the limits, right? So it takes two inputs like minimum and maximum. 0 is the minimum, maximum we're providing us 5,000. Why we have given this in this case? Because when we are plotting the dependence, so by default it was coming till 3,000 or 4,000 only, right? So which absolutely does not look right. 4,000 over here if you see, and actually even one category we have almost till 5,000, and that's the reason that we have increased the limits till 5,000. Okay, so for that, which is by default it should be right, but as it is not, it's a limitation we have, so we are explicitly we are referring ylim as 0 to 5,000. Okay, so in your script you have example for this. From your base package you have this dependence phone service commands. So you can see that. So over here for phone service, we have two categories, added one color code, and mention the x-axis name, y-axis name, and the title of the plot. Okay. Well, over here, the ylim argument has not been used in these commands, but I would say you could just add on this argument as well for your practice point of view. Okay, so let me just share this command in the chat box. Well, even if you're not able to copy the code, in case if you're not able to copy this code, you could still just look into the command. You could write it from your own as well. Just add this ylim is equal to C0, 5,000. Okay. All right. So Smithy has going to show the phone service column. Yep. So plot customer churn dollar phone service. Okay. So we are just adding color code over here in the second command. In the third command, we are just adding xlab, ylab, and me. Okay. So you could use table customer churn dollar phone service. You have two categories. These are the two columns that we have. Okay. Well, if you see over here, it showed almost till 6,000 stuff. So the value is a little bit greater than 6,361. If I like to remove a, I could use rm function a. Okay, rm a, it will remove this. Okay. So let's say I've created a 1:100, and then I'm creating b, which is 1:10, and then c, let's say 1:1000. Okay. So I have ABC, and I would like to remove A, B, and C. So I could just mention A, comma, B, comma, C. Okay, so all three would be removed. Now let's say I would like to remove all the data that we have right now in the global environment. Okay, so let me just create all of this A, C, B. Okay, so I do have A, B, C customer churn, 4 data sets. Okay, if you just use ls function, you would be able to see all the data that you've created so far. If I like to remove all of them, whatever I do have, I could use rm function, list is equal to ls. So this is the command that you could use to remove every data that you have in the global environment. Now, the same thing. So let me just show an example. A, B, and C, if you do have. Okay. So there's another way of to remove. So over here, you can see there's a brush sign where it mentions clear objects from the workspace. If you click over there, it will show you this pop-up. Are you sure you want to remove all objects from the environment? This operation cannot be undone. If you click yes, everything will be removed. Okay. So it's like, this is the command wise that you could use to remove everything from your data frame, from your global environment. And there is manually if you just click from there. Okay. Well, right now, I can't get back whatever I've created. Okay. So be cautious whenever you're using this RM list as well. Okay. So now I have to read the data again. Okay. In your contract column. Okay. So if we see next, if you try to create contract. Okay. Now let's look into the table for contract. Customer churn dollar contract. Now you have 3 categories in contract. Okay. And we have used the plot function for this. Now, if you just use plot customer churn dollar contract, you'll see 3 different bars for each of them. Now, if you see this particular one is having a number higher than 3000, whereas the value limit is showing till just 3000 itself. All right. So you should typically be increasing this. And if we see just the table, it shows that maximum is still 375. So we could just keep it to 4000, right? So how we could do that? Just add volume over here, right? Comma volume. See, minimum 0, maximum we can keep till 4000, right? Zoom it, we'll see that it is still not 4000. Next, you would be willing to just add xlab ylab main and with some color code. Okay, so comma this, you get a better visualization now. Okay, yeah, so volume is for volumes. Okay, so if you see this one, as you see that the default one when we created, right? So this one, the actual bar is above our limits, y limits that we have. It's a very bad way of visualizing it, right? So y limit is actually not covering. So how would someone understand this is 4000 or less than 4000 or greater than 4000 as well, right? So this is something should not be happening in excuse me, in your visualization. For that, to change this, we are giving a limit to this. So y limit is for y limit, x limit is also there, which is for x limit. Why you're giving the minimum and the maximum value? Okay, it's just a vector, it takes as input. So minimum we are providing 0 and the maximum we are providing is 4000. Why 4000? Because we see that the maximum value we have till 375, and it makes sense that to have a number something even greater than that, that's absolutely okay. Okay. All right, so this is the univariate analysis for a categorical. Now, how about if it is a numeric? Okay, for numeric, you can't do this, right? So you don't have categories over there, right? So it's just, for example, monthly charges or total charges. Let's say if you take these columns or tenure. So in that, every number could be unique, correct? And for each value, you won't be seeing their frequency. So what you could do over there for numeric variable is, what we do is we create histogram. Okay, histogram in the base package, we have the hist function. Now what it does is, let's say we do hist customer churn $10. Okay, now it creates certain beans. Okay, so well, in the base package, we call this breaks. There's an argument called as breaks, which are nothing but each individual bars that you see. These are like, we are calling it as beans, or let's say breaks, whatever you call it is. So in base package, we have the argument called as breaks. In ggplot, we have called as beans. So what it does is it creates a particular range, and for each range, it shows the frequency. So both in your, if you see in your histogram or bar chart, your y-axis remains the same. By default, it's a frequency. Okay. In histogram, as it is a numeric column, you don't have categories. So it creates the category like within a particular range. So for example, 0 to 5, 10 to 15, 15 to 20, like this. Okay. And this number of breaks are something could be changed also. Okay, so it gives you a default one by whenever you create a chart, but you could change this by using the breaks argument. Okay, so there's an argument called as breaks, for example. Okay, so if you just mention, let's say over here, breaks is equal to 10, so that means it will try to create a chart where it would have 10 beans at 10 bars at least. Okay, so it will try to create 10 bars, but it does not also guarantee that it will have 10 bars on it. Okay, so it has like 0 to 10, 10 to 20, 20 to 30, 30 to 40, like this. Okay, so with the change of the breaks value, you could change the ranges at which you would like to see the individual bars. Okay, and for that particular range, it shows the frequencies, like tenure 0 to 10, how many customers are there, 10 to 20, how many customers are there, like this. Okay, all right, now over here, let's see that over here there's one more issue that we found, right? So when we just use the base one, the very first one, you see that there's an issue with the X limit, right? So as we are just talking, the way we have Y lim, we have X lim as well. Okay, so over here you could mention, let's say X lim 0 to 80. Okay, so if you see the maximum value, so if I just do max of customer churn dollar tenure, you have 72. So you can keep, let's say it's increasing by 10, so you could keep till, let's say 80, that's fine. Okay, the arguments remains the same, xlab, ylab, main. So by default, your y-axis name has been given as frequency, so it's okay. Xlab, it's better you change it, so you mention as tenure. Now over here, you see there are two colored codes, one for CL, another for border. Okay, the name itself is says, so CL for the color of the bars, border is for the boundary color. Okay, keep a note of these argument names because this two argument will be getting changed in ggplot command. Okay, so in base package, CL is for the color of the bars, and for the boundary color, it's border. Okay, so for example, if I execute this one, so it has this true blue color for individual bars and the border as white color. Okay, we have changed the name for the x-axis, y-axis, and the title of the plot. So which looks better, but after certain changes that we did, right? So I've mentioned over here that xlim and ylim parameters are arguments, which is something we could use to change the x limit or the y limits. Okay, CL is to define the color of the individual bars. All right, so one question, what is the unit of tenure here? So it's in months. Okay, so a quick way to know about the distribution of any column is you could use a summary function. So summary of customer churn dollar tenure, if you do, it shows you minimum, first quartile, median, average, third quartile, maximum value. So we'll talk more about each of this, like quartiles and all, again in detail in our statistics module. So tomorrow I'll be discussing about this. So it's just saying what is your 25th percentile, what is your mid value, the 50th percentile, the average, the 75th percentile, and the maximum value. See, so as I just mentioned about this. So quickly, you could just check with this one itself, right? So for example, in this case, you mentioned till 70 on. Okay, now it shows it's 0 to 10, 10 to 20, 20 to 30, like this, till 70 as per the breaks. And then you mentioned, let's say, all right, so it should be till 70 itself. All right, so it should till 70, but it extending till for the rest 2. So that means 71 to 72. It should certain them, right? Yeah. So that would impact. Okay. So if you just make it to 80 as well over here. Okay. So in this case, it will show you like till 80 itself, right? So which actually concludes from 70 to 80. Okay. All right. So one question that you have asked on, can we put the individual numbers on each bar? So in this using this base package, you won't be able to. So we'll see the same functionality like you're typically asking about the data levels. So that we would be checking in the ggplot. Okay, it could be done over there. So this functions typically the base package we typically don't prefer much. Okay, so specifically we directly go for the ggplot commands itself. Okay, okay, or the moves. Let's say you say. Now we use scatter plot for two numeric variables. Okay, both x and y should be numeric variables. So we see that with the increase of x-axis, how y-axis moves. Now the question comes that if both are numeric, so how do we decide which one shall I keep in my x-axis and which one shall I keep in my y-axis? Well, anyone would like to give it a try, saying that like why we would keep this variable in X and why shall we keep the other in Y, let's say. Now we are using both numeric features. Okay. So let's say we have this tenure column and another total charges. So we'd like to see the relationship. So how do we decide that? Which one shall I keep in X and which one shall I keep in Y? Okay, Saumya mentioned could choose any, Ramna says any. Okay, so how do you decide which one is dependent and which one is independent? And next question would be mine that, okay, if it is, you know that which one is dependent, which one is independent, then which one will keep in X and which one should be in your Y? All right, so above that there's mentioned X independent variable, Y dependent, depends on dependent variable. All right, so Sanjeev has mentioned X are permanent sets. Amitav has mentioned dependence in X. Soumya has mentioned dependent on Y. All right, so Emmanuel has mentioned X, so Y dependent, X independent. Right, absolutely. So we decide based on which one is dependent and which one is independent. Okay. So whenever we try to see the relationship between two variable based on domain understanding, we try to understand that. All right, so which one should be my dependent and which one should be independent. In this case, let's say tenure and total charges. Right. So tenure of the customer is not dependent on his total charges, right? So tenure is independent. Whereas total charges, how much is paying to the organization, that is dependent on how much old is there in the platform, like in the what's the tenure of the customer, right? Based on the tenure, his total charges would be dependent. So y-axis, we typically always we keep our dependent variable in our y-axis, and independent variable would be in our x-axis. Okay, please keep a note of this. This is important point. Whenever you're visualizing, make sure you don't mix mistakes in this stuff. Okay.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following is a false statement about data analytics? A. It collects data. B. It looks for patterns. C. It does not organize data. D. It analyzes data. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
X should be independent and Y should be dependent. X is equal to customer churn dollar tenure. Y is equal to customer churn dollar total charges. Type is equal to P, I have mentioned, if you see over here. This is not needed because by default type is equal to P only. But why I've mentioned, because just to let you know that there are other types also, like type is equal to P, type is equal to L, type is equal to B, you can keep. P is for points, okay? L is for lines, B is for both, like line and points both together, okay? PCH is equal to 20 that I've mentioned. So it's a plotting character, a symbol to use. If you just open this one, so I've mentioned over here, like default is 16, like it's just a dot. 20 is also kind of a dot itself, just a smaller one. 16 is this one, 20 is this one, nothing big difference, okay? So like these are just numbers, like how we would like to represent this, okay? Just mention PCH is equal to 20, XLab, YLab, and main. If you see, these remains the same. Okay, so if I just plot this, here's the graph based on the tenure, how my total charges varies. Okay, so whenever you would like to see a relationship, there should be a meaning in that, right? So you'd like to see, all right, so if my this variable increases, what is the relation with the other variable, like how the other variable would behave, right? That's the end object. So don't think when you visualize what is independent, what is dependent. Okay, so just you need to have the end objective clear, like why you want to visualize or what you're expecting to visualize. So in this case, the objective is to understand with the increase of my tenure of the customer, how the total charges of the customer vary. Okay. And then now, okay, if you like to now visualize, okay, now then you think that, all right, so between tenure and total charges, which one is independent or which one is dependent? All right, so tenure is independent. So I keep tenure as x-axis, total charges is dependent on tenure. So I'll keep y is total charges. Okay. So whenever you're visualizing, first thing, you need to keep clear that what exactly you're trying to visualize, okay? Why you're visualizing. Let's say you like to understand the distribution of the customers who got churn. So you create bar chart because it will just show you the number of observations you have under each category. So P is point. Okay, so if you see these are just individual dots, right? These are points. And PCH is just the point shape. If you see the black dot that you see, this is the like the value. So if you which I was just showing over here, like PCH 20, if you see the 20 number is for this point. Okay, so typically default is 16, like the bigger circle, so 20 is the smaller one. So default is P, P is for point, okay, L for line. So typically if there's time series kind of stuff, there's a trend, so where we use line chart, okay, and then you have B, like both point and line. So scatter plot, we use this type is P on, okay. So if you don't mention anything, default is P on, okay. To change this range, we use this breaks argument, right, which are nothing but the number of bars or the beans, whatever you call it is, okay. That is something which your definition breaks. Now scatter plot, there's no concept of breaks over here, right? So it's just a relationship between two numeric variables. Every data point that you have is getting captured over here, right? So how exactly it's creating, if you try to understand this. So let's do one thing. Let me show you in a better way. So I'm creating a data frame. So let's use the select function itself. Select customer churn, comma, customer ID, comma, tenure, comma, total charges. Okay. So what we are trying to do is, if you see, for each customer, there is one tenure and their respective total charges, right? And so if I sort this, you see, so for these customers, right, from 1 to all the customers that we have their total charges, okay, and that is like we are trying to visualize. So for 1, these are the total charges. For 2, these are the total charges. 3, these are the total charges. Okay, that is something we are visualizing over here. Okay, all right. Now let's start with understand ggplot visualizations. Okay, so all the ggplot commands which we'll be discussing, they all follow very similar syntax. Okay, the first thing that we need to do is to understand the syntax of ggplot. Okay, so let's first spend time in understanding the syntax. So we'd like to create, let's say, histogram, okay, for the same tenure column, which we just made using this hist function. So the first is to create the plotting. Okay, so we use the function called as ggplot. The package name is ggplot2, but the function name is ggplot. Okay, keep a note of this. The first argument is data always. Okay, so we mentioned data. The argument name is not mandatory, so you could ignore this also. You could directly write your data frame name, that is your customer churn. Okay, and the next thing is very important, which we call it as mapping. Okay, so mapping means we provide the aesthetics basically. Okay, so we use a function called as AES function, which is nothing but aesthetics, where we provide the mappings like X and Y axis. Okay, so for example, for histogram, there's only X axis. Okay, there's no Y axis. So you just mention X is equal to the column name. Now, if you see, this is like deploy package. Okay, so as we mentioned the data frame name over here, we need not to access the columns using $sign. You can directly mention the column name. Okay, now for this AES function, a very important point is that for any purpose, if you like to use the column names, you have to use it inside your AES function. Okay, so this is one important, very important point that you need to remember for ggplot commands. This is the only one source of error I typically found that people they initially the students make. But if you just take care of this point, it becomes all your code very simple. Okay, so column names when you be using, like for x-axis name, for y-axis name, you might be also willing to use color code based on columns. Okay, that also you could use, but in that case you have to mention inside AES then. Okay, now if you just run this one, okay, it won't create any plot for you. Okay, all it will be doing is just create a chart area for you. Okay, like tenure x-axis, that's it. Okay, now what we do to plot is we add geom layers. Okay, so to add layers, we use this plus sign, and then we use like the geom functions, like there are various geometric geom functions that are available. So for example, first thing is like to create the plot, right? So for that, we have the various geometric elements, so using geom function. Okay, now for example, we would like to create histogram. So for that, we have geom underscore histogram. Okay, that's it. If I just hit enter, it will create the plot for us. It just mentioned that stat bean using beans is equal to 30, pick better value for bean width. Okay, this is not an error, just a suggestion saying that you could pick better value for beans. Default beans is equal to 30. Now, in the base package, whatever we have mentioned as breaks, that is equivalent to beans in ggplot. Okay, so nothing but the number of individual bars. This bar is itself one is calling as beans. Okay, now for example, you could mention over here beans is equal to 20, let's say. Okay, that's it. Now, next thing over here, if you see the default, you get x-axis name, y-axis name. There's no issue of the x limit, y limits. Cool enough. But again, if you like to give the color code and the boundary colors to separate the individual bars, right? For that, to give the color code to individual bars, we have the argument called as fill. Okay, this is different, which we have then used in the base package. Base package, we have used CUL argument, right? In ggplot, CUL is used for the border color. Okay, so let's see this. So let me use steel blue 4 for fill. Okay, and CUL, let me use just white for the boundary color. Now here we see that same graph, just much better than the previous one because we give the right color code over here. Okay, and the next thing is, for example, we would like to change the x-axis name, y-axis name to add title of the plot. Okay, now all of this we could do now by again adding layers on top of it. Okay, so plus you have xlab function. Okay, you could just use xlab tenure plus ylab. Ylab is not needed because count is fine, so I can ignore ylab. Now to add title of the plot, there's a function called as gg title. Okay, so which is a part of ggplot itself. Title is like tenure distribution. Okay, so it just made a better visualization now for us, like that of the plot as well. Okay, all right, now what else that we can do over here? We could add certain other column also to on top of this. So all right, so let me talk about that after this. First, I want all of you to execute this piece of code. Okay, so what you have to do is just run this piece of code. Okay, so just play around it first. The base one, just change the beans to 50, beans to 20, and over here just add this xlab, ylab, and title of the plot. Okay, which we have just seen so far. Okay, A is for aesthetics. Okay, so anytime you'd like to add any mappings like accesses based on the column names, you have to use inside AES function. Okay, all right, so Samya, one good question. So x label is shown without x label as well. Why are we using again x label? So over here, if you see, the reason I've changed this is by default it was the column name was in lowercase, so the column name itself it would be shown. So I just made it as T in the capital. Okay, that's it. Yep. So they will be coming into that part. All right. So Kunal, the question there was, what is geom histogram? So this is a function that if you like, so this is a geom layers that we have. Okay. So would like to create a geom histogram, we'll be using this geom histogram function. Okay. So this particular syntax remains the same for any ggplot. Okay. So we like to create bar chart, histogram, scatter plot, box plot, any plots, we'll be using the same syntax. So plus we add the geom layer. Like for histogram, we have geom underscore histogram. For scatter plot, we have geom underscore point. For bar chart, we have geom underscore bar plot. Okay, like this, we have like different functions for each of the different charts. Okay, and again, the names is up to you that what exactly that you like to give the name for x-axis, y-axis, and title of the plot. Okay, all right. So Pratyush, the error that you've got could not find the function ggplot. So I would request that please load the package. You have to install the package at first using install.packages within codes ggplot2. So in the beginning of session, we just talked about that. To use ggplot, you have to load the package ggplot2. Okay, so please run this command and then you could execute the ggplot codes. Okay, so right now, as we have just one independent variable, like it's a histogram where only x-axis we need to mention. We are just referring x is equal to 10. All right. Now, one thing that if you just observe carefully that over here, there's one issue that sometimes this might, in histogram, you might find in ggplot that it's not starting exactly off from 0. Okay, so just to make sure that it starts off exactly at 0 only, you could mention this argument called as boundary is equal to 0. Okay, so if you mention boundary is equal to 0, it will start from your x-axis 0 only. Okay, and you have another argument called as bean width also, which is also either beans or you could use bean width. So beans, like, it recommends that or you mentioned that, all right, I need 20 bits. Okay, so it's a kind of approximation that your histogram will try to create. Okay, and bin width is like what should be the width of the individual bits, okay, that you're willing to have. So you mentioned like bin width of 5, so it's like 0 to 5, 5 to 10, 10 to 15, 15 to 20, like this it will create. Okay, and if you see now, it starts off at 0 only. Okay, all right, now coming to the next point where we would like to add this.
Just a quick info, guys. If you are looking for data analytics course, then we have a good news for you. Intellipaat is providing an advanced certification in data analytics for business with IIT Madras. The course is of very high quality and very cost effective. The course link is given in the description below. Now, let's continue with the session.
Another column on top of that. Okay, that means another column means we are checking now the distribution of tenure only, but among this group, okay, so which we just talked about, like this one, we have pins 20 and all. Now over here, I would like to just add that among this set of customers, what is the distribution of partner look like? How many are partner and how many are not partner? Okay, or how about the behavior with respect to churn? Okay, among this set of distribution of customers, how many got churn and how many didn't get churn? So what I would do is, instead of color code as steel blue 4, okay, I'm just removing this fill is equal to steel blue 4, and over here I'm adding this fill argument is equal to, let's say I would like to add churn call. Okay, so I could remove CL also, that's fine. Rather I could, I think CL black would make sense in this case. Okay, so what I've done is, in this command, fill argument I've mentioned as churn, and so the border color given as black. So what you could observe over here is, so by default it has chosen 2 different colors for each categories of churn. We have not mentioned anything on this color code. By default it would choose 2 different colors. The fill argument I've mentioned inside this AES. As I was mentioning, anytime you have to use color code based or anything column name, you have to use it inside AES function. Okay, so fill over here, I'm not using color code, rather a column name. So I'm using it inside AES. Okay, so what it's trying to do is, it's the distribution remains the same, but the color code we are referring based on churn, like from 0 to 5, 5 to 10, 10 to 15, like this, whatever distribution that we have. Now, among those ranges, what is the distribution of the churn customers, right? And one observation clearly that we could see from here is that with the increase of tenure of customers, the churn rate is also decreasing, correct? Irrespective of the frequencies of customers that we have, the ratio is remains a pretty similar trend, that it's decreasing with the increase of the tenure of the customers, right? So over here, you're just not letting one information, that means just the distribution of tenure. You're also able to visualize that with the increase of tenure, our churn rate is also decreasing. Okay, this is a kind of important stuff where, all right, so we have the information for the churn also that we are trying to visualize. So over here I've mentioned bean width is equal to 5, boundary is equal to 0. Okay, with a clean explanation saying that, all right, so the increase of tenure, our churn rates are also decreasing. Okay, so this is a kind of quite important stuff many times, where if you like to add on certain other analysis also on top of your histogram, like so this becomes just a bivariate analysis in this case. Okay, so whenever you're creating histogram, you could also try this out, that if any important point of interest, we have like churn column. Okay, so churn is major interest in this analysis. So you might be interested to see that, all right, so this distribution of tenure, also see, let me see that, is there a relationship of the churn with respect to the tenure of the customers also? And you could easily understand this trend by just visualizing this, right? The end objective remains the same, right? That you would like to understand that over here, the distribution of tenure on, and on top of that, within each range of the tenure, among them, you're seeing how many is getting churned. So Soumya, fill is nothing but the bar colors, the individual bars, what color code that you're giving, right? We have used any color code, random color code till. So over here, if you see, you have used fill is equal to still blue 4, correct? This is one, just a color code that you have given. Now, instead of this color code, you are trying to provide, you're trying to see that, all right, so within the 0 to 5, this many customers, we have the number of customers within this tenure 0 to 5. This many customers, 10 to 5 to 10, 10 to 15, and then 15 to 20, correct? Now, your objective remains the same, that you want to see the distribution of customers, but let's say within this 0 to 5, 5 to 10, how many got shipped and how many didn't get shipped, right? In that scenario, you could just add saying that, all right, so let's do the color code based on churn column. Okay, so you just added fill is equal to churn, which you will be mentioned as churn is a column name. Okay, you have to use it inside AES function. Okay, and that's what you're doing now. So you have just changed that fill from blue color to based on the churn column. Okay, your y-axis change nothing, right? So y-axis again still remains the frequency on. It's still your histogram on. Okay, so CL is black is the boundary color, right? So CL over here in ggplot refers to the border color. When you will keep fill or anything inside AES, mappings like x-axis, y-axis, this would be always your column, correct? So for example, histogram, only x-axis you need to mention. So it has to be inside AES. Fine, cool enough. Next, coming to the color codes. You have two arguments that could be used as color code. One is fill, to fill in the inside the bars. Second is COL, to give the boundary colors, correct? Now, if you'd like to give the color code, that means red, green, blue, any color codes, you have to use inside the geom function, okay? But if you like to give a color code based on a column name like this, like I would like to understand the pattern, whatever chart I'm creating based on churn column, okay? So that has to be given inside AES function, okay? This is something you need to remember over here while using this ggplot. I would say, please run this command so that you understand what would happen. So try using this fill is equal to churn inside geom histogram, you will get error. Try using codes over here, which will give you an error. So once you check, try out things, you'll understand that when to use which one. Okay. Fill. So see, you need to just understand this, like the difference between these two. Fill is to give color code inside the bar, and COL is used for the boundary color. This is fixed. Okay. For ggplot, this is the syntax. Okay. You can't use the boundary color using fill and inside color using C. Okay. COL is just for the boundary color, nothing else. All right. So let me explain it again. Let's make it clear again. Okay. I'm creating this ggplot. First is data frame name. So I'm requesting everyone to please listen to this carefully. We are mentioning AES aesthetic where we want to create a histogram. So only x-axis is needed. Okay. X-axis, y-axis name would be always typically column names, right? So which we would be always giving inside AES. Cool enough? Everyone clear on this? So we are just mentioning tenure. We don't need y-axis because it's just a histogram which needs x-axis on. So we are just providing x is equal to 10. So y would be by default in this case count, which it will calculate for us, plus geom histogram. Okay, cool enough. Over here, let's say over here, let's add this bins is equal to 20 in this case. Okay, and now if you see this is the chart that we are getting. Okay. Now, if I just add CUL is equal to white. Now, can you tell me what exactly it did? So I've used this CUL argument. So what change it did in the chart? Exactly, the boundary or the border color, right? This is something you need to remember. In Geom, in ggplot, CUL is for boundary color. When we are using this bar charts like this, wherever you have bars, CUL is for the boundary color. Okay. Now, if I add fill a color code, still blue 4 is one color code. I'm just giving this color code in this case. So what it did, just fill, that means it's filling in the bar colors. All right, cool. Now, the next thing that we are talking about over here is that our objective over here is the same chart, same visualization. We are trying to create histogram. We are trying to see the distribution of tenure column. Now, on top of this, I would like to also understand, okay, that how the distribution of the churn customers look like now. That means, is there anything that churn is dependent on this tenure of the customers also, that with the increase of tenure, like, is it happening the distribution wise, the churn rate is varying or not? Okay, so I would like to understand that also. Now, that means this could be easily done just by mentioning the color codes of these individual bars using the churn column. Okay, that means which one shall I change? The fill argument, right? I would like to change this individual bar colors based on the churn column. So I would remove this fill from here. Okay, and I would be adding this inside AES because I'm using a column name now. So I have to use it inside AES only. Okay, so I'm giving the column name churn over here. Okay, inside the fill. CUL I can keep white. Let's see how it looks like. Okay, so over here, if you see, what it did is the border color is now I do have white. Okay, and the color codes has been changed based on the churn column. It has to, in churn we have two different categories, yes and no. So it chosen default, by default, two different colors. Okay, by default right now it has chosen two different color codes from its own, as it has two categories, churn, yes and no, and it showed the distribution for each of these bars. Okay, like when to use inside AES, when not to use inside AES. Yes, this color, which by default it has changed, it has used like red and green. I'm just naming this red and like sea blue color, anything. So this you can change using another function, which we'll discuss later. But right now it has some chosen some default stuff. This color you can also mention explicitly. Okay, yeah, yeah. So right now, if you don't mention anything, it will choose this default color. Okay, yes. Now, so if you like to add numbers on top of the bars, yep. So Bhavdita, you have your view right now. Let's talk about this, the syntax which we're using to get this one. So over here to get this, we have to use stat underscore bean. Okay. Now, as we mentioned, the number of beans over here, the same number of beans we have to mention inside stat underscore bean function also. Okay. So geom is going to text we need to mention. So this syntax is something you could like keep a note of, like whenever you'd be using this, you have to use the same syntax. There's no variation that you would be having. So only thing you need to take care that in geom histogram, whatever number of beans you'll be mentioning, the same number of beans you have to mention over here. So label is equal to something we are referring AES, label is equal to dot dot count dot. This is a syntax which we use over here to let the function counts based on the number of beans that you have. Dot dot count dot dot means it's a syntax, but like for the ggplot where it calculates the default one. Okay, default one means whatever number of beans that you're mentioning, like let's say for each of the beans, it will calculate the frequencies. Okay, and that you're visualizing by mentioning over here as geom is equal to text. Okay, now v just is vertical adjust minus 0.5. That means if you give a negative value, it will show the values on top of the bar. If you give a positive value, it will show you the number below the bar. So how much above or how much below the number you'd like to display, that is something, the value you could adjust. Okay, 0.5, 1.5, 2 or plus 1.5 plus 2, anything that you could adjust. Okay. Another thing I've added over here just to make better visualization. If you see alpha, I've added over here 0.5. Alpha is like transparency to the color. Okay. So if you just don't use alpha over here, this is something that you'd get when we used alpha is only 0.5. This is the view that we'll be getting. Okay. Now, next is I've added over here theme. Okay. So inside this plot.title argument you have where this element underscore text. So these are something you could use for the labs and the theme function. So instead of using xlab, ylab, gg title, you could use just one function called as labs, where you could mention title, x-axis name, y-axis name like this, instead of using 3 different functions. Okay. So this will give you a plot like this, where you have all the bars with the numbers, with the title of the plot over here. Now what we have done over here, element underscore text, it just is equal to 0.5 we have mentioned. It just means horizontal adjust. It takes 3 values, 0, 0.51, 0 by default, where if you see the previous charts, by default when you plot, so for example this, it showed you the title of the plot in the left, extreme left, right? So if you mention it just 0.5, it will show in the center. If you mention in the 1, that means it will show you in the extreme right. Okay. Face is bold as it is making in the title bold. Okay. All right. So cool. So you could just execute these 2 pieces of code as well. Okay. So this one was 105 and 111 commands. So there's no explanation for this. Whether this is just a regular syntax, where what it's trying to do is just counting the number of observation. Okay. So the default way of counting 20 over here, we are mentioning whatever number of beans that you mentioned. So it will count what is the frequency that you have. So this is just the syntax. I would say whatever value the default way of counting. So this is the way it has been written in R itself. Okay, while developing the function. That irrespective of whether you write this or not, if you see stat underscore bin, we have not written anywhere till now, right? So it's using this by default AES label dot count dot only to calculate this. Okay. And this function like labs theme function, you could use for any ggplot. It's not specific to only histogram as shown over here, but something you could use for any type of chart. Okay. These are generic functions, just like xlab, ylab, gg title.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following method creates a new array object that looks at the same data? A. View. B. Copy. C. Paste. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
You could also use this labs function where you could mention all title X and Y. And this theme function you could use for any ggplot functions. Okay. In your real-time projects, there's no hard and fast rule. The business, if I talk about in terms of business, I'm not talking about your particular company, particular team wise. In general, if we talk about the real-time projects in the business scenario, they really don't care specifically in the business presentations that which tool you have used for making the visualization. Okay. You're presenting something, all they care about is the story or the insight that you would like to present. Is it shown or not? Okay. They won't ask you which R programming, which function, which language you have used. Okay. If you have like to present something, you're in the tough deadline and you have the data with you in Excel. Instead of you importing this into R, load the ggplot package and write this 10 lines of code just to create a histogram, and which would take just less than 30 seconds to create in Excel. Which one would you prefer? Definitely the Excel, right? And the very same chart, the same color codes with same data labels you could do in Excel less than 30 seconds, right? You would prefer the Excel itself. And really, it really does not matter in that scenario, whether using Excel or R program. Okay. Now, coming back to this one, like why we would be using this then? Like, why can't we just do everything Excel then? Okay. Now, uh, this is what I've just mentioned is the scenario that to just mention that it's not mandatory or it's not right to say that you have to only use R or Python just to visualize. So you can, Excel, you have tough lines. You want to just quickly visualize and see the distribution, go for Excel. Okay, no worries about that. But for example, let's say you have loaded the data, you're working on an analysis, you made some data manipulation. Now you want to visualize this distribution of 10. And on top of that, how it varies with respect to churn. Now, let's say you don't know how to visualize all this using this. Now, what you have to do in that case, you export the data, you take that into Excel, and then you visualize this, right? And now you see the challenge that you have. Now you are dependent on Excel to visualize this, correct? Which by the time you have exported, import, like in Excel, you're visualizing it. By the time you could have just written this code, or you could just write down and just visualize it, right? So that is one thing that why is it again needed to know in R. Secondly, for a lot of such kind of tasks, which you would like to do it multiple times, and for everything, you won't be doing this in Excel, right? Something that you could just quickly see in different ways, change it, do it in the same platform, you would be doing each and every task, right? Not like for each task you'd be using Excel, for other you'd be using Python, for another you'd be using Tableau, or each and every different stuff, right? In the same tool, you'll be doing all of this particular task.
We're going to talk about transpose function. We created an object by help of R-bind in previous case. Now, if you want to convert into from row bind to column bind, so there is function called T, that is transpose. So transpose help us to to change dimension from row to column or column to row. Like this is the current dimension. If I write transpose D, so it will reverse its dimension. That is what all I did with the R bind, I can convert into C bind. So that is the basic application of T, that is the transpose. So transpose help us to change the dimension, that is to alter the dimension from row to column or from column to row. Now we are going to talk about merge function. So this is here the concept of database management comes in, and in most of the platform we talk about merge, and those merge are in SQL this is known by joins. So joins are a type of merge. So we're going to create data frames, different data frames, and in those data frames we'll perform certain merge. Here a data frame is created. Name of data frame is capital A, and we are taking letters from 8 to 12. So essentially 8 to 12 means we are counting from alphabet. That A is taken as 1. Likewise we are going up. So an element A is created. If we talk about the value of A, so this is how it looks like. There is a variable called later. Later start with small l, and we are using later function. So later takes value from English alphabet and creating a variable. There is another variable called A, and the values go from 1 to 5. So this is how this data frame is created. Now we are going to create another object called B, again using the same later option. So here in later we are saying sample. We are not saying from 8 to 12. We are saying any of the letter you take from A to Z. I need 10 alphabets between A to Z, and that could be randomly anything. And then we are using some uniform number, 10 uniform number, and those uniform number could be anything. So we are completely randomizing. So we are using the random alphabets as well as random numbers. Now here it takes a random alphabet. So that could be, if I run second time, you will see that this number will be something else. Here it starts with EAH. If I run second time, it essentially do not start with EAH. Something else has come because we are talking about the randoms. So more and more we do the experiment, we get different combinations. Now here we are talking about some uniform numbers. So these are taken from random distribution table. These are all random numbers following the normal distribution. So I'm not going in detail about random distribution here, but it is essential to know that this helps us to create some random numbers using the random distribution. Now I'm going to merge both the tables. We know that in first table there was a variable called later, like in my table A, that is in data frame A, there is a variable called later and there is a variable called A. So in later it is I was very specific to take letters from 8 to 12, and for value essentially take from 1 to 5. In second case I was not very specific, so I simply took some sample of alphabet, the 10 alphabets, then I use some uniform number to take the value. Now what I'm going to do, I'm going to merge both together. So the moment we talk about merge function in R, by default it is inner join. So inner join is what? Wherein it is only the intersection of the values which comes in. That is, if there are two different data frames, and if I run inner join, so in that case, what all are the common in both the data, those data will come. And how the common is measured? So it is measured by help of the variable which is common in both the data frames. So here in our case, later is common in both the data frame. So later will be used to find the common value. That is, technically it is called a primary key. So here by default my primary key is later. So the moment I run it, you see what all are the common in both the places, like H, I and J. The three letters are common in both the tables. So accordingly, these three letters are taken and the value of A and B, that is the remaining non-common variables been put together. So the role of merge is to put values together by help of some primary key, that is by help of some common variable in both the data frames, and accordingly the value comes in. Now we have another option which we can activate as a user defined value. Now in previous case, the moment you simply run merge A and B, wherein A is my one data frame and B is another data frame, so it runs inner join. If I write all is equal to true, so in that case, it perform full outer join. That is, it concatenate value from both the table of matching and non-matching both together. If I run this, you see, we have these are the matches which is available in both the tables or in both the data frames, and these are the non-matches. So you see, somewhere you will find NA that is not available. So KL is not available in B, whereas the value of A is not available in your first table, that is first data frame. So this is equivalent to full outer join. So previous case was inner join. This is how full outer join is done. Now, if you want to perform something very similar to left join, that is, we are interested about all the values from the first table and the matching values from the second table. If matching is available, give us matching. If matching is not available, give us not available. So in that case, we write all dot x is equal to true. Here x is what? My first table. So that is how it's written. X is your first table and y is your second table. So here we do not write all dot a or all dot b. That is not the way. We always write all dot x, wherein x is my first table. The moment I run this, I will get the similar output the way we saw here. If I want to run the right join, so in right join, what exactly we are saying that we want all the values from second table and the corresponding matching value from the first table. So in that case, we need to essentially write all dot y is equal to true. Remember, as a protocol or as a programming provision, we need to first specify that all is equal to false. That we are not going for full outer join. We are simply saying that we are interested for the left join. So these both terms have to come together. Otherwise, we do not get the desired output. Then we need to decide that is it left join or it is right join. So this is example of right join, wherein the moment we run it, we get something wherein the values from both the tables are taken, considering the second table as a reference table. So here second table is my reference table, and accordingly value been incorporated or value been put together. So that's what all example is given here. Here it is talking about all is equal to true, that is full outer join. Then here all dot x is equal to true, that is left join, and all dot y is equal to true, that is the right join. So that is how the entire join process works. Now there is another function which help us to split the values like it's the written the cats sat on the mat. If I want to split the different letters and want to put uh, a balance code for that, and so here a space I want to put in between. So in balance code there is a space that is called delimiter. I'm saying that my delimiter is the space. So this help us to split the different strings. So this is called splitting the strings. That's the reason str is written. That is string split. So we are splitting the strings and putting those strings, and there must be a blank in between. So blank is what my third argument is. First argument is function, second argument is the value, and third argument is the delimiter which I want to use. And essentially I am saying one because I want it split one letter, one and one letter. So in case you want to split in more letters, That is 2 letters together. You can increase it 2, 3, 4, whatever you want. Like here, the same thing is written. If I run it, so you see this is how been split. Now the best part of this is even the space is considered as a character. That's the reason that here you see here the space is given in between. After the, that is TSE, there is space. So that space is also considered. Now we're going to talk about metrics. So metrics creation in R is very useful understanding. A matrix is a combination of rows and columns, wherein we define the dimension of rows as well as the dimension of columns, and accordingly a matrix is created. So let's see some example of matrix creation. Here we are creating a matrix called M. So for matrix creation we use function matrix, and we are saying that we are going to use function C, that is, and the value for C we are saying 1, 2, 3. We are saying number of rows is equal to 3 and number of columns is equal to 3. So what essentially it does, it creates a 3 by 3 matrix wherein value of each column is 1, 2, 3. That's how this matrix is created. That is 1, 2, 3, 1, 2, 3, 1, 2, 3 for all 3 columns. Now, if I want to do matrix addition, I want to add 2 matrices together, because matrix creation is done. Whatever value we put here, accordingly this matrix is created. We want it to have a matrix with value 1, 2, 3. That's the reason that 1, 2, 3 is written. You can write any of the number, and accordingly a similar matrix is created. Even you can write a series of number to give a different value to the different element. That is how in complex matrix structure we usually write different numbers. It's not the same number for each and every column. So now, at the basic level of matrix creation, this is how a matrix is created. Now, if you want to do the matrix addition, so we simply write M plus N. That is matrix plus matrix. So here, like 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is equal to 6. So that is how the matrix addition happens. So we understand that the basic functionality to create a matrix, then this is how the matrix addition happens. Now we are going to create some complex matrix. The way I mentioned that we can create a matrix with the different numbers. It's not always the same number for each column. So we are saying that we are going to create a matrix M using C function. Inside C we are using sequence. Sequence is what we are saying that create a matrix from certain number to certain number. So we are saying create a matrix from minus 98 to 100 by 2. That is minus 98, minus 96, minus 94. Likewise, it has to go up. And we are saying number of rows is equal to 10 and number of columns is equal to 10. So essentially this is 10 by 10 matrix. So in 10 by 10 matrix, the total number of element is supposed to be 100. If I talk about these numbers, if you compute, we'll get there are exact 100 elements, that is 100 numbers. If you want to see matrix, this is how matrix is created. So it starts from 98, minus 98, and using this by option, we are adding 2, 2, 2 in each and every iteration. So first is minus 98, second is minus 96, minus 94. Likewise, it is going up. So a 10 by 10 matrix is created. Now we are going to perform certain mathematical tasks over this matrix. So the first task is to return the product of each of the rows. I want the multiplication of each of the rows, that if I multiply the entire stuff, each row together, what will be the value? Like minus 98 multiply minus 78 minus multiply minus 58. So what will be the value? For that, we this one indicate for row and two indicate for column. So we are saying that this is row wise, and we are using the product, that is multiplication. We can use sum, or there are more mathematical functions which we can use, but essentially we are using the product, that is multiplication. So it says that this is sum of your first row, this is sum of your second row, third row, fifth, sixth, seventh, 1, 2, 3, 4, 5, 6, and this is for the seventh. So that's the reason that 7 is written here. So it essentially writes about the number of the element. So here number of element is 7. So remember, in output a new line always start with a square bracket. Inside square bracket some number is written which talks about the number of the element, that this number is a what is the element number of this value. So it is talking that it is the seventh element. Now if I want to sum up to the each column, so for sum we are using the sum function, and for column we are using 2. So it will sum up each column. So that's what it's saying. Here we created a sequence of the matrix 10 by 10. Then we created a product of each rows. Here we created a product of each column. Now we are going to talk about, we will discuss about the C bind. We have three objects called A, B, C. Use C bind, that is column bind, and with the column bind we bind all values together. So now we create a new object called D, wherein these entire values are given. If I want to compute the row mean, so this is how the row mean is computed. Let's see in our environment. This is A, this is B, this is C. We are using C bind, that is column bind, wherein A, B and C, all three vectors are bind together. So our element D is created. If we want to compute the row mean of the D, this will give me the row mean. If I want to compute the column mean, this will give us the column mean. So this is how we compute mean on the top of the C bind or the R bind. Likewise, we can compute row sum or column sum the same way. The way we created uh, row mean and column mean, we can create row sum and column sum. The function is the same. Here we are using C bind to bind the values, then creating row sum, that is summing the entire rows. So the value is coming. We can create column mean as well. So this is the column mean, that given standalone. Likewise, column sum, So this is row sum, this is column mean, this is column sum. So it's only the function. We need to remember the functions being used while writing these programs. Now we're going to talk about the vectors, more and more about the vectors. What exactly these vectors are. We saw in previous case that we use C function to create a series of elements. So essentially, the moment I talk about vector, vector is always one dimensional. So dimension could be horizontal, dimension could be vertical. Like here, we are creating an object called x using C function, which help us to put values together. So I'm saying that the x object has three elements, 1, 2, 3. If I print x, so either we simply write x and run in editor, or we write print under bracket.
Just a quick info, guys. If you are looking for data analytics course, then we have a good news for you. Intellipaat is providing an advanced certification in data analytics for business with IIT Madras. The course is of very high quality and very cost effective. The course link is given in the description below. Now, let's continue with the session.
X that does the same task. So both are the same. Let me run in our environment. This is X we create. If I want to print the value of X, so we write print X. So that comes like this. Even if simply write X, that will also give you the same result. So print X is written only in our environment, not in our studio, wherein we have essentially in when we talk about only R, so this is the only interface which looks like. So it is only the console. There is the remaining three windows are not available in R. So it is only the console which is available to write and debug the entire program. So that's the reason that print X. So the moment you work in only console, so in that case we need to write print X. Only X does not work in console.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following is a false statement about data analytics? A. It collects data. B. It looks for patterns. C. It does not organize data. D. It analyzes data. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Here we are creating another object called Y. Essentially, the moment we write print Y, it is printed like this. We have another sequence. There is another function called sequence. So this is how we talk about print. There is another function called sequence. Sequence help us to create a series of values. The way we saw in matrix creation, where we use sequence and then we use by option. So here we are saying that sequence 1, 2, 3. So it creates element 1, 2, 3, or we simply write like this. So both are the same. Either we write like this style or we write like this style. Both will create the same output. Now here we are saying that we are going to create some element using sequence function and saying by is equal to 0.5. So remember, by default in sequence, 1 is the inflator. So every time the iteration happens, the value inflates by 1. In case you want to change the default inflators, so we can use the by option. So by help us to specify the interval, that is the inflator, we are going to use to inflate the value. Like here, we are saying that my inflator is 0.5. So my first element is 1, second element is 1.5, third element is 2. If I do it 0.25, so I will get something else. So it is inflated by 0.25 units. So that is called the inflator. That is the increment which happens. So that is how it's written here. So we are using 0.5 as an increment unit, that is inflator. Now the same we discuss about this concept. We are using repeat function saying from 1 to 3. So it is we are saying that write 1 3 times. So that's the reason repeat is used. Here we are saying start from 1 to 3 and write it 2 times. So here the role of comma is very important. So comma in case of repeat function, whatever comes after comma, that talks about the frequency. That we are saying that write from 1 to 3 having a frequency of 2. That is, repeat this value twice. That's what we are saying. Like we're saying, this will simply create an element wherein 1 is written twice. If I say start from 1 to 3 and repeat twice, this is how the output is supposed to come. Now we are going to talk about indexing. So indexing is what wherein we try to find out the value of certain element. Like here I'm saying create an object called E, and the value of E is 20134. I'm saying that I want first element of this object. So we are using a square bracket. Inside that square bracket, I am saying that I need first element. So it will give me 2. 2 is the first element. If I write 3, I will get the third element. Now, next time, I'm saying that I'm going to create an object called e-index. So e-index is what? It is an object, and the value of e-index is 1, 2, 3. So that e-index is created, and for that, what here essentially what are we doing? We are using the e function, and we are using e object, and inside that we are using e-index. So e-index, e is what? E is my, it's an object, and e-index is what? It is another object. So value of e-index is what? 1, 3. So essentially what are we saying? So if I talk about the technical interpretation, so this is 1, 2, 3. So this both are same. If I run this, so here we're talking about, this is from, I'm talking about element 1 and element 3. Essentially here we are, that is the same stuff. Either we write like this or we write like this. But here what happens in this case, that the multiplication, the multiple, you can say indexing is not always applicable. So in case you want to write the multiple index, we used to write like this, or inside that we use this function. Remember, these both are the similar stuff. Both will give you the similar output. The first, this is first method is used by help of indexing, and the second method is used by help of user specified value. So here technically we are performing the same task at both the places. We have some other functions like mathematical functions like min max that we can apply. So I would say that we are creating an object called x and the value of x is minus 1, 2, 3 using min function. So min return us the minimum value, max return us the maximum value, and mean, that is average, return us the average value, that is mean. So this is x. I want to compute minimum of x, that is minus 1. Want to compute maximum of x, that is 3. And this is average of x, that is 1.33. Now, if we want to perform certain mathematical operations like adding x with x, so we are adding minus 1 with minus 1, 2 with 2, and 3 with 3. So that is how the addition happens in case of a vector. If we create a vector, we can do vector to vector addition, vector to vector multiplication. So multiple options are available. Subscripts are basically, this is part of the element, that is part of some object which normally we try to find out. Like suppose there is a vector called y, and if I am interested about the third element of y, so this is how it is written. If I am interested for third to seventh element of y, this is how it's written. The moment we talk about element, essentially I am talking about the rows, that how many rows I want. If I want a series of, this is 3 to 7, that's what it's saying. It is talking about the series of element. The moment I am interested about some unique elements, so in that case, this is how we take help of subscript to obtain the part of the vector. So this is called getting part of the vectors. Here we are creating an element called y. And the value of y is from 1 to 9. Now suppose we are interested about only the third element. So under big bracket, we need to specify the position of the element, that for which element we are interested in. We are interested for the element number 3. That's the reason that 3 is written here. If we are interested for a series of elements that starts from 3 and goes till 7, so this is how we write. Now we are interested for a particular element. This is not series. It is more than one element, but essentially not the series. So in that case, we use C function, and accordingly we write the position of the elements, that which all elements we are interested in. Now, if I am interested to drop certain element from a vector, so in that case, we use negative sign. So here, essentially we are saying that we are going to drop the first element from the series. So if I talk about the values of y, so these are 1 to 9. But the moment I drop the first element, you see it starts from 2 to 9. So first element I dropped. So this is what essentially we're talking here. To drop element from the arrays, use negative subscripts. So the negative subscripts, the way we saw, that's how it's written. Yeah, this is how we drop an element from an array, that is from a vector. We can drop an element. Now we're going to talk about some logical commands. Suppose from a series or from a vector, we are only interested about the values which are greater than 6. So in that case, this is the notations, or this is the logic we write to get a value which is greater than 6. So if I'm interested about those values which are greater than 6, so this is how we write. We are essentially, the first element is the the, the first member of this syntax is the vector we are specifying, and second part of the program is the logic which we are supplying. So essentially we are talking about the values which are greater than 6. Now here another example of logical variable is given, wherein we are saying that we want those element from y to whom if we divide by 3 we do not get any remainder, that is the exact multiple of 3. So remember, when we use double percent sign, it indicates about the remainder, that is the value which is left out when we divide y by 3, and this is essentially here we are saying it's not equal to 0. Fine. So the moment we say it's not equal to 0, so we are interested about those values which are not exactly divisible by 3. Now we are going to talk about arrays, that how exactly arrays are written. So essentially arrays are the combination of multiple series. Like here we are saying that we want to write a number from 1 to 30, wherein there are 5 rows, 3 columns, and there are two series of these arrays. That is, this this array consists of two different series. So in first series, we are specifying, we are from 1 to 30, we are saying that it's the entire number which we are going to consider, and this is what we are specifying about a dimension. The first two letters are the dimension. We are saying that 5 row and 3 columns, and 2 is saying that we are going to have we are going to split this one from 1 to 30 into two parts. So you see, the moment I run this script, how exactly I'm getting two different series. This is the first series from here to here, and this is second series from here to here. So it says that my first series starts from 1 and the second series end at 30. That is what the entire range I'm specifying. Now I'm talking about the dimension. Here I'm saying that it is of 5 rows and 3 columns, and this series is divided into two parts. So there are two parts of this series. Now, if we are interested about the second or third column of our data, like here, we are saying that though we created a series called A, out of that, I'm interested about second and third column. Remember, multiple commas been used here. So the value which comes before first comma, that indicates about the rows. So here we are not specifying any rows. It means we are talking about the all rows of element A. That is the series which we created. From that series, we are interested about all the rows. The second argument which we are supplying is essentially we are talking about the column. So we are saying that we are interested about the second and third column. And the third argument is talking about the series. Is it series 1, series 2? So we are not specifying anything here. That is, by default, it will take both the series. So there are three parts of this arguments. So under this argument, my first part is the total number of rows. So I'm not specific about rows, so all rows will come. Second is about the column, and third is about the series, for which series I'm talking about. So here I'm saying that I'm interested about all the series, second rows, second column, third column, and both the elements. So in that case, I'm getting the second column and third column, both the series and all the rows. Now, if I'm interested about the second and fourth, from second to fourth rows, second and third column, and only the second series. So in that case, we can write like this. Here, we are getting values of from second to fourth row, from second to third column, and it is talking about the second series. This is what we saw. So we need to be very careful while writing a subscript, that under a subscript the value which comes before first comma is your rows. The value after first comma is your column, and the value after second comma indicates the element, that which element we are essentially talking about. Now we are going to talk about list. So essentially in R, by help of list, we can create an array of element. So what technical difference between list is? We talk about vector, we talk about matrix, we talked about data frame. Now we are going to talk about list. There are some fundamental difference between all these four different types of object available in R. So a vector is essentially one dimension. It could be horizontal, it could be vertical. A matrix is, of course, it is of two dimension, that is there are rows and there are columns, and that could be of any combination. But essentially it is numeric. Even we have scope to create a character matrix, but in that case those characters are converted into numbers, and essentially we create 0 1 0 1 kind of, 0 for no, 1 for yes, likewise. So that is what the matrix is. The moment we talk about data frame, so data frame is very close to matrix, but a data frame consists a combination of numeric and character both together. So that could be numeric only, that could be character only, that could be combination of numeric and character. Now, the moment you talk about list is a kind of different types of object put together. So there is no concept of rows, columns, likewise. These are different objects put together. Like you can think list a, a wardrobe or a drawer wherein you put different objects together, but different objects are not essentially related or you can say connected with the other objects. These are all standalone. So list is a kind of, you can consider list as a drawer wherein you can place a lot of stuff together. So that's what we are essentially getting here. We are creating a list wherein my first element is some name, second element is some number, third element is some color. Let's see how does this list look like. So I'm creating a list called car. So this is what my list is. So in my list, there are three arrays, or you can say there are three different types of elements available, or there are three different types of vectors available. So my first list of element is name of some brands. Second element is some number, and the third element is some color. So essentially, there is no dimension issue. My first element has three dimension, second element has three dimension, wherein the four dimension has the third element has the four dimension. So that could be of any of the dimension. Now, if I want to see my first element, first arrays of the elements, so in that case, this is how the way is. So in case of list, we need to specify double square brackets. So inside double square bracket, we write the the element number, we write the vector number, or we write the array number. Essentially, it's the vector number. So we write vector number. We are talking about vector 1, vector 2, vector 3. In our case, this is vector 1, this is vector 2, and this is vector 3. So the moment I run this, I get vector 1. If I run this is the second element, and this is the third element. So this is how a list is created. So we talk about, in previous slides, we discuss about vector creation, we will discuss about data frame creation, we discuss about matrix creation, and this is the next kind of object in R, that is called list. So if I run like this, I get the first element, this is for the second element. Now we are going to talk about reading data from external files, and this is how usually we get data for the analysis. So this is a bit tricky, but we need to understand about database connectivity, or you can say to bring data inside our environment. That's what we are going to talk about. So in R, there is concept of working directory. So working directory is a place that is the default destination to access the data, or even to save the element. So now, in case we want to know about the working directory, for that the syntax is get working directory. So the moment I run get working directory, I get the place where which is my default directory at this moment. So whatever I do, whatever object I create, if I want to save this object, by default it will be saved or stored at this place. Now, if you want to change your working directory, so in that case there is command called set wd, that is set working directory. In previous case we saw the command was get working directory. Now this is set working directory. So under set working directory we set the place where exactly we want to read or write the data. And in R we need to be careful about the slash. So it is double slash is what usually use. It does not take the default extension of or the default location of the files. Doesn't mean single slash is considered in different way in R. So that's the reason that we take help of double slash. So the moment we need to specify location of a file, we need to be very careful that this is double slash, not the single slash. Other path, I'm talking about the path. So in terms of path, this is how the double slash, manually we insert double slash the moment we copy path of a file. Now, suppose we are interested to read some delimited file. So in that case, the command is read.table. So read.table help us to read a file which is in my default working directory. So this is the file name, and I'm talking about header is equal to true. That is, do we want my data with the headers or without the headers? So headers means the variable. Are we interested about the variable including the variable name, or this is without variable name? So if we are interested about with the variable name, so in that case we need to specify head is equal to true. If the objective is to read a CSV file, so in that case we initiate with read.csv, and essentially we write the file name, and here the extension of the file is .csv. Reason being we are reading a CSV file, an extension of CSV file is .csv, and here we are saying the header is equal to true. Now in our case, suppose the second is either we write read.csv or we write read.table, the way we saw in first case. So we can read CSV file in both the ways, but essentially the moment we write read.table, so we need to specify the delimiter, that what is my delimiter. So of course this is CSV file, so my delimiter is comma. So I'm saying test.csv, this is my file name, header I'm saying true, and the separator, that is delimiter, is the comma. So there are two methods to read a table. This is for text file and this is for the CSV file. So we can read CSV by help of read.csv or by the help of read.table. Both are equally applicable, but the concern with the read.table is we need to specify the delimiter. That what exactly the delimiter we are talking about.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following method creates a new array object that looks at the same data? A. View. B. Copy. C. Paste. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now we are going to talk about the plots, how plots are generated in R. So there are multiple types of plots, and plots are associated with different features like x-axis, y-axis, the name of the plot, colors, then edge it with the dot, the connecting lines. So that's all we are going to discuss here. So the first is the line plot. We are going to talk about the line plots. So essentially for line plots, we need some value. So here we are creating a vector called cars, and for that there are some user specified value, that is 1 3 6 4 9. So these are the value been specified. Like there is a object called car, and that is created. Now we are going to plot. We are essentially talking about a line plot. So we're going to draw a line plot. So for that, the function is plot. By help of plot, we can plot a line plot specifying the object. So here my object is car, and using the function plot. The moment I run it, a plot is created here. So this is how the default behavior of the plot is, wherein my y-axis is the values which I specified, like 13649, 13649. So this is coming like this. So that is the default plot, wherein we are specifying only the dimension, one dimension. So in that case, y-axis is my default dimension, and x-axis is taken as an index. So those indexes are not very relevant. Reason being, it talks about the element. This is first value, this is second value, this is third value, this is fourth value, this is fifth value. So it only talks about the sequence of the value, the way it comes to the data. Now I'm going to plot the same thing here, but I'm adding some more and more option. So what exactly I'm doing? I'm using the plot function, specifying the object, and I'm saying type is equal to O. O is what? It's the overplotted. That is, I'm connecting these dots together. So this is called the smooth lines. I'm creating something called smoother. It's not smooth, but this is the connecting lines. So type, so there are multiple options we have. So if I replace, like here, in this case, this is line, connected line which comes in. So for connecting the lines, we use this type option. The moment I replace this type with P, so I will get only the points. There is no lines. Fine. So we have multiple options. If I replace it with L, I will get only the lines. There is no points. There is no dot. So we show all three options. So O is what? O is basically a combination of line as well as point. But if we are specific about only the points or only the lines, so we can specify. The moment I replace it with H, that is a histogram kind of structure, so I will get something which comes as a histogram, that is bar, that is length of each and every value is given here. So we have multiple options in that. Now we are going to create something to add some title with the plot, some colors, some font. So I'm saying that plot to that, the plot which we have created. On top of that, I'm saying main is equal to autos. So main is equal to what? Is the name of the plot. So auto will come here as a name, that as an index, as a header. It says that the name of this plot is auto. I'm saying color of main is what? It's red. So the font of this auto will come in red color. Now I'm saying font dot main. So here I'm specifying the size, that how big it should look like here. So main is what? It's the name of this plot, or you can say the legend which we associated with the plot. The color dot main, that is col dot main, is what it talks about. The red, if I replace it with blue, so we'll get in the blue color. So that the blue color has come. Now the font dot main is what basically it is talking about the font size. So there are predefined font size in R. It's not essentially like Excel wherein the font the numbers are directly correlated with the size of the fonts. Here it is true in some cases, but it's not true in each and every case. So for more information about font, you can go to the help directory and we'll get information about the font being used in R. So essentially I am using font is equal to 4. So there are different font size. If I write 3, so it will go to 20. But in that case, the moment we increase the dimension of my y-axis, my graph it tends to go down. Reason being, my highest is 9 in my data, but the scale, essentially it is talking about the scale, but the scale which I am taking, that is going till 20. That's the reason that in case you want to give a good look to your graph, so this y limit is essential. I would suggest in that case rather use 10. That will give you a graph which is very close to the final value of your y-axis. Now the same thing we are going to do with the second vector, that is with the truck. So here I'm plotting again. We are saying that lines, the value is what we are going to do. With the trucks we are going to do, we are saying type is equal to O, and we are there are another option that is called PCH is equal to 20. PCH, it's basically it's a point of shape. Fine. So these are the multiple options available in R, wherein the PCH is essentially talking about the shape of the point. Then we have LTY. It is talking about the line type, that what type of line is. So there are some default line types. 2 is for the dashed.
Just a quick info, guys. If you are looking for data analytics course, then we have a good news for you. Intellipaat is providing an advanced certification in data analytics for business with IIT Madras. The course is of very high quality and very cost effective. The course link is given in the description below. Now, let's continue with the session.
One is for the solid lines. So there are multiple types of line. So this is for the line type, that what type of line, because we know in previous case by default my line has come like this line, but now I want to differentiate it. So I'm going to create a dash type of line so that I can differentiate. At the same time I'm specifying some other color so that it both the lines do not look similar like this. So this is the objective. So what exactly I'm doing, I created one plot, and inside that plot I'm inserting a line graph on the value of trucks. This is my vector. I'm saying type is equal to O. That is, I wanted to have a connecting element. Then PCH. This is talking about the shape. So here exactly we are talking about the box. In previous case, this was circle, but here I'm talking about the box. So this is PCS 22 is essentially for the box. If you change it by 20, I'm not sure what will come. So this is how the shapes are supposed to come. So there are different shapes type in R, but the the popular types are 22 and all. So that's what we use. So you can specify your shape type, that in which shape region being the objective is to differentiate between both the shapes. And then we are talking about the line type. Is it dotted? Is it solid? The moment I do it one, it will be the solid line. It is a solid line, the way it comes in the previous graph. Now I'm talking about the color is equal to red. Reason being wanted to differentiate between both the colors. So this is best part of R in graphics, wherein once we create a plot, on top of that plot, you can add more and more number of plots to have a combined impact, or to have a combined visual appeal from the of the different elements. Now we are going to add title with that. So we saw about the title. I'm saying that main is equal to auto, color of main is equal to red, and font of main is equal to 4. So this is how uh, a plot is created with two different vectors. Now we are going to talk about the bar plot. So for the bar plot, essentially we need some vector. So my vector is cars. I am saying bar plot of car. So this is how the bar plot looks like. So as I mentioned in previous case, that we need to be very careful that if we specify a vector which is of course vector is of one dimension, but the moment this is only one now, it's a vector, and you specify either bar plot or line or whatever, the y-axis is taken as the default. So that's what it's saying. It is saying the my first element is of height 1, second element is of height 2. Likewise, it is coming up. First element is 1, second element is 3, next element is 6, then element is 4, and the last element is 9. So accordingly, it takes height of the element and it goes up. So we talk about the line plots. So this is what we created. We define a car vector with 5 values. Then on top of that, we plot, specified the type is equal to O, that is the connecting lines, connecting points we wanted. Color is equal to blue, that's what our objective was. Then we added some titles to the plot with the main and color dot main and the font dot main. So these are the options. For the line plot, this is what we saw. We simply we create multiple values together, and we are saying that graph car using an y-axis that range from 0 to 12. So that's the reason that we use the y-lim, that is y-limit, and essentially the type is equal to O, color is equal to blue. These are the previous options were discussed. Now we added more lines. This time I'm using a vector truck and type is equal to O. Then here essentially we're talking about the shape. We're talking about the type of line, that is this is for the dotted line. The moment you change 2 from 1, this will be a solid line. Then we're talking about the color of the line, is it red, blue, whatever you want. Then we added some main and title to the plot. Now this is about the bar plot. The way we saw, we create a vector for that, and on that we simply added a bar plot option. Now, in bar plot, we are going to talk about more and more about bar plots. So exactly, we are adding some, we are doing some value addition in this plot. So my element is, my vector is A. On that, I'm using bar plot. In previous case, we saw the moment we write simply bar plot, it looks like this. A very simple bar plot comes. Now here I'm saying my object is, that is the value on which I'm going to create my plot is A. Main is what? It is a legend, or you can say the name of this graph will come. Now I'm saying X lab. So by default, X lab has no value. But now I'm saying X lab is equal to days and Y lab is equal to total. So I'm saying this will be the total value. So here for axis, I'm defining the name. Now here I'm assigning name dot arg. So I'm saying for this value 1, 2, 3, 4, this is 1, 2, 5, 4, 3. I'm assigning value like Monday, Tuesday, Wednesday, Thursday, and Friday. Now I'm saying border is equal to blue. So if the graph is plotted, so what is the border of my boxes? And essentially I'm talking about the density. Density is what? I want to differentiate between different days. So here the density is uniform. I mean the way this plot, this bar, the color in this bar is the same color is used in this bar. But here I'm saying it's not so. I want different density inside these boxes so that someone can easily differentiate. Let's see an example. This is what exactly I wanted to explain. That I'm saying that I'm creating a plot, a box plot, a bar plot on a vector A. Main is equal to cars, that is coming here. X lab is equal to days, that is here. Y lab is equal to total, which is given here. And now, essentially for each and every element, I am assigning the name. I'm saying this one correspond to Monday, two correspond to Tuesday. So that's what it is coming here. Now, I'm saying border is equal to blue. That's the reason that blue borders are there. If I say border is equal to red, so we'll get the red borders. So now my borders are red. So this is how this border option is used. Now I'm talking about the density. I'm saying that I want to use different graphics, that the density of the graph of the line which is coming in box, that should be different so that I can differentiate it. So I'm using density 10, 20, 30, 40, 50, so that I can differentiate it. You can change density as per your convenient. Now essentially this density is being used to focus on certain days. That depends on your priority. Here I am saying that I am prioritizing my days the way it is going forward. So that's how this number's been used now. And this time I am saying no, I am prioritizing 2 days, that is Tuesday and Friday. So I'm using 100 for this. Then third priorities, I'm going to this third element, that is Wednesday. And the last priority is on Monday and Thursday. So the moment I run like this, we'll get likewise density. So here it is apparent that density of Friday and Tuesday is the same, whereas density of Wednesday is next to these two values, and density of Monday and Thursday is the same. That's how you can change the density to differentiate between different bars. That is to differentiate between different boxes. So likewise, we create an object. In our case, we took example of one case. When we say that bar plot A, that is the value on which this bar plot is plotted, main is equal to cars, X lab is equal to day, Y lab is equal to total. Name essentially we are writing like this. Then for the borders, we are saying blue, red, whatever you want. And density accordingly you can specify. The first example we saw wherein density is written in ascending order. The same thing is written here. But here we are saying color is equal to rainbow. The moment we say color is equal to rainbow, it comes as a very colorful kind of. So it comes as a rainbow colors. So here the different lines being used in different colors. So these are a default option. in case of rainbow, if we see the syntax, I'm saying that border is equal to blue, density is what, and color is equal to rainbow. And why this 5 is used? Reason being, we are saying that there are 5 elements in here, so must use 5 different colors. So we do not have command over here on the color. It takes the random colors, but it tries to differentiate between the color of the different boxes. So that is how the default behavior is. In this section, we are going to talk about pie chart creation. So objective is to understand that how pie chart is created and what are the integral components for pie chart. Here we are going to define a car vector with 5 values. That is, there are 5 values for this car vector, and these values start like 1, 3, 6, 4, 9. So now, on using this data, we are going to create a pie chart. So here I am defining a vector called car, and on top of that I am going to create a pie chart. So for pie chart creation we use a function called pie. Then by help of main option we give a name to this pie chart, that is the body of the pie chart. Then we are going to use color as rainbow. So rainbow is what basically it comes as a default setting with multiple colors. Then we are saying length is equal to car. So we are specifying the length because though we are using the color option, so we need to say that how many colors we are going to use. And in order to specify different colors, we are using this length option. Then we are using labels to say Monday, Tuesday, Wednesday, Thursday, Friday. This label will be used for each and every element of this vector. So likewise, we have a pie chart, and the name of pie chart is car, that is used with the main option. Then using a color option called rainbow. So this is a function wherein we are specifying the length of the colors, that is how many colors we are going to use, and accordingly we are writing the labels. So label is for different pies that we are going to consider. And that's what here entire explanation is given, that create a pie with the defined headings. So we are using a heading by help of main option, and then using color option. This is color function to specify with the rainbow option, And we are saying the labels, that how many labels are required for the pie chart creation.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following is a false statement about data analytics? A. It collects data. B. It looks for patterns. C. It does not organize data. D. It analyzes data. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, here we are going to add some more and more value to the pie. So exactly what are we doing? Again, we are creating an object called car, and with that, we are specifying certain color. Define some color ideal for the black and white print colors like white, gray 70, gray 90, gray 50, and black. So these are the different colors option available in our background. So we need to essentially use these colors. Then we are going to calculate the percentage of each day, then round it to 1. So exactly we are using some formula, that is car, that is number divided by sum of numbers multiplied by 100, that we are converting into percentage, and we are specifying that how many decimal places we want. So essentially we talk about a vector creation, then we talk about a color option. In previous case, color was rainbow. So in that case, color was used randomly considering the rainbow function. But here we are very specific about the color of different cells, that is color of the different pie. Now we are computing the percentage of each pie. How much is the percentage? Then we are using a concatenate function to concatenate the car level with the percentage. Like suppose 25%, I want to write this red line option creates the percentage of each and every pie. But now we are adding a percentage sign with each and every pie, that should be visible in the output, that should be visible in the pie chart. Then we are combining these all previous option, like we are creating a pie on car, main is equal to car, color is equal to colors. The colors option which we specify here, we are using that colors option. Label is equal to car label. The label which we use here, that is for the decimal places. And CX is what exactly? This is used to give certain magnitude of your output. Let's see that. So here we are defining a color. Then in this option we are creating a fraction of each and every cell. Then here we are associating label with the percentage sign. In here we are creating a complete pie chart using the all previous options. So this is what exactly we wanted. So here my main, that is body name is car, then color, what all colors we use in previous cases, then label, and we had discussion about CEX option in some of the previous graphics creation. So that is how CEX is used here. Now we are going to talk about the histograms. Histograms are essentially it is a way to display the occurrence of different event. The moment I talk about the occurrence, essentially it is the frequency of different elements. So it's a combination of different bars together. with certain numbers, certain values comes with that, and which essentially indicates about the occurrence of different event or different sales altogether. So for that we are going to use a library called Lattice. Lattice is a library. So essentially we need to install dot packages and then write Lattice. That is what first we need to run this option. That is install dot packages. Then we need to activate this library. So now this library is activated. So essentially what I'm going to do, I'm going to create histogram on 1000 numbers. These numbers are the random normal numbers. That's the reason that R norm, that is random numbers, this is how we specify the random numbers. And then we are using a int is equal to 30, which help us to associate these random numbers with the output. Then we are using xlab, that is x label is equal to what? So what is the value I want to write at the x label? And then we are saying what is the color. We are going to use the color as sky blue. So that is how it works. So either we use a user defined value for the histogram creation, or we use some random numbers. Here objective is to discuss that what is the method to create a histogram. So this is the ideal method wherein we are taking some random numbers, and these random number consist of 1000 random numbers, what we are saying. And then we are saying that what is the x lab, what is the label for the x label, and by default y label comes what is the default setting. So here we are not specifying anything for the y label. We'll see in detail about the y label creations, but here objective is to just incorporate the x label with the output. So with the histogram we incorporated the x label. So this is what about the histogram. We talk about pie chart creation, we talk about histogram. Now we are going to talk about the analysis of variance. So this is the first statistical technique which we are going to talk. So analysis of variance is essentially used when we have two or more than two groups available and we want to compare the mean of each and every group. Once again I am going to repeat. Analysis of variance, that is ANOVA. 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 Analysis of variance is essentially used in a case wherein we have two or more than two groups and the objective is to compare these groups to find out is there any statistical significant difference between the mean of these two groups. Like one example, suppose in an organization there are male and female. We want to compare is there any kind of statistical significant difference between the salary of male or female, or some another example is given. So statistical method for making simultaneous comparison between two or more means a statistical method that yield value that can be tested to determine whether a significant relation exists between variables. So essentially here we try to know about the difference of the mean of two or more groups. Like if you want to compare, there would be more and more example. One more example is given. A car company wishes to compare the average petrol consumption of three similar models of a car and 6 vehicle of each models. So what essentially we are saying that we are considering 3 different models and 6 vehicle of each model. So we have altogether 18 cars. Out of those 18 cars, there are 3 groups, there are three different varieties of cars, and we are using 6 cars from each group. So we are going to compare all 3 groups together to find out that how is which car is similar to other, or which group is similar to others, or which group is dissimilar to others. So it helps us to find out the the difference between the mean of different groups. Now the question comes, manually we can compute the mean and we can say that the mean of one group is higher than the mean of other group. Yes, that we can do. But essentially, when we talk about the difference in mean, we are talking about the statistical significant difference. We are not talking about the overall average difference of the mean. There may be overall difference in the mean exist, but that should not be statistical different. The moment we talk about statistical different, there is certain measurement to compute or to say the difference into the statistical uh, standpoint. So it's not as a overall difference in the mean. We talk about difference considering certain certain statistical assumptions, certain statistical procedures. Another example is given. A teacher interested in comparing the average percentage mark attained in examination of 5 different subjects and has the mark of the 8 student who all completed each examination. So we have 5 different subjects and we have 8 students. So we want to compute that is there any statistical significant difference between the score obtained by the student. We'll see more and more example. So essentially, what ANOVA looks at the way group differ internally versus what differences between them. So it seems a bit complicated, but essentially what here we try to do, here we compare each and every group with others, then we try to do a overall comparison clubbing all groups together. So the process of ANOVA calculations can be explained taking the examples given here, that ANOVA calculates the mean of the each group, then it calculates the mean of all group combined, that is overall mean, then it calculates within each group the total deviation. So here we are talking about a deviation, and deviation is what? It's basically the difference which come across. The total deviation of each individual score from the group mean, that is within group variation. So here we talk about overall mean and we talk about within group variation. Then we calculate the deviation of the each group. So overall mean, within group and each group. That's what. So there are three different types of mean computation. One is at the overall level, second is group wise, and and then we compute the deviation of the each groups. That how the deviation is there. For that, we'll be using some data set available here. But before that, I would like to talk more and more by help of some Excel sheets available with me. Now, let's consider we have 3 different samples: sample A, sample B, and sample C. So in sample A, there are 5 values. In sample B as well, I have 5 values. In sample C, I have 5 values. That is, I am saying that this is the the numbers from group A, this is number from group B, and this is number from group C. So in first step, what we do, we first compute the mean of each and every group. So this is the mean. Then we try to find out the difference between the mean and the value from each group. So here 2 minus 4 is what the difference is. Here 3 minus 4 is the difference. Here 7 minus 4 is the difference. So here we compute the difference. So this cell computes the difference. Then we square it up. We multiply the difference by the difference itself. So what exactly we are doing? E4 multiply E4. So we are squaring it up. And the moment we square it up for each and every element of group A, we sum it up. So now here total sum is 22 for this group. So for sample A, this is sum of the difference. So we can say that this is sum of the difference. Similarly for group B, the value is 10, 8, 5, 7 likewise. So and the mean is 8. We compute the difference. Likewise, we square it up and sum it up. For group C, we perform the similar task. Now, then we add up all differences together. That is 22 plus 18 plus 14. So that is what done here. So we added it up together. And the sum is 54. So this is called sum of the squares within group. So this is technically this is called sum of the squares within group. So we need to be careful. We are talking about within group. So there are certain terms which talk about with group. Here we are talking about the within group. This is 54. Now in second step, we put all values together. This is of the first group, this is of the second group, and this is of the third group. We put all values together, then we compute the mean. So if you see, this is the mean is 8.33, that is written here. And then we perform the same task. Value minus mean, that is 2 minus 8.33, the value is given. 3 minus 8.33, this value is given. Likewise, it is going up. So we perform this task for each and every element. Then again we square it up. That is minus 6.33 multiply with the minus 6.33. We did for each and every group. And again we sum it up. So my sum is 257.33. The sum is coming here. So this is called the total sum of the squares. So remember, we are using different terms here. In previous case, we call it sum of squares within group. Here we are saying sum of the squares, total sum of the squares. Now, in third step, exactly how is the process? Again, we put all values together. We compute the average, that is mean. This is my first group, wherein average is this. This is my second group, average is given. This is my third group, average is given. Now, this is called X bar. That is the mean of each and every group. Now, here I am saying it the mean of total group. So I am saying it xt bar, that is mean of the total group. Now, so we need to I use different terms so that we understand that how this calculation is going on. So now I am computing x bar, that is mean minus x total bar. So exactly what I am doing, 4 minus 8.33, that is computed here. Likewise, for the second group, I am computing 8 minus 8.33, that is 0.33 is given here. For the third group, 13 minus 8.33, that is 4.6 is given. So now here I computed difference between two groups, that is overall mean minus individual mean. Then I am squaring it up. So minus 4.33 multiply with minus 4.33. Likewise, we square it up. Then we are multiplying this square up with the total number of observation. So I know in my first group there are 5 observations. So I am multiplying this with 5. So 18.77 multiplied by 5 is 93.88. Likewise, here 0.11 multiplied by 5 is this, 21 multiplied by 5 is this. So this multiplication with the total number of element is there. Then I am summing it up. So the sum is 203. So here sum is given. So all three values are summed together. Now this is called total sum of squares. This is called sum of the squares between group. I'm sorry. This is called sum of the squares within group. So we know that here this is 257. So how the relation is, we computed three values. One is sum of the squares within group, that is 54. Then we computed sum of the total sum of the squares, that is 257. And now this is sum of the squares between group 203. So we can essentially see that 257, that is my second calculation, is sum of my third calculation and my first calculation. So this is sum of these two values. So now I am moving into more and more calculations. So calculation number 1. Here the value which we computed 203, what exactly we do? We divide this value by the total number of groups minus 1. So in our case there are 3 groups. So we are dividing 203 by 2. Because there are 3 groups, so we need to divide it by number of groups minus 1. So this value is here. In second calculation, whatever sum we obtained from my first calculation, we need to divide it by total number of element minus total number of groups. So there are 15 elements, 5 in each group, and we are dividing it by, and from 15 we subtract 3, there are 3 groups, and the calculated sum of squares in first case is 54. So we are dividing 54 by 12. So this is 4.5 is what my second calculation is. Now here we compute the F ratio. F ratio is essentially the value which comes through calculation 1 divided by the value which comes through calculation 2. So this is called, the F ratio is 22.6. Now this is F value. Now we are going to talk about the degree of freedoms, because essentially we are going to use F table. So for F table calculations we must have degree of freedoms for numerator and denominator. So for numerator, how the degree of freedom is computed, that is total number of groups minus 1, and for the denominators, total number of elements minus number of groups minus 1. So that is what essentially the term we use as to divide both the values. So now what exactly we are going to do? We are going to calculate F. We are going to see F value in F table with degree of freedom as 2 and 12. 2 and 12 we calculated here. And here the calculated value at 2 degree of freedoms, 2 and 12 degree of freedoms is 22.6. Let's see into the F table. there is statistical table called F table. In the statistical table, F for the F distribution, a value corresponding to 12 is here, it's given. So for 12 in case of denominator and 2 in case of numerator, the value is 3.89. If we see into the plot, but our calculated value is 22.6. So this is exactly 22.59 something. So this is my calculated value is 22.59, and this is the value which is coming from the table. If I look into the distribution of the table, I can essentially say that no, this value is outside the cutoff value which I am supposed to get by 2 and 12 degree of freedom. So if something comes in outside the cutoff region, that is called a rejection region. That is, here we reject the null hypothesis and we can easily say that no, that there is at least one group in the entire calculation whose mean is significantly different from the others. So that is how the interpretations or how the explanation goes on. That we computed some F value for a given data, then we looked into the pie chart distribution, that how the value is distributed. Then we try to figure out that is it coming inside the selection region or outside the selection region, that is the rejection region. So we found that our calculated F value was 22.6 with 2 and 12 degree of freedom, whereas in F distribution table the value for 2 and 12 degree of freedom is 3.89. So we essentially say that no, we are going to reject the null hypothesis, that is at least one of the group from the data is significantly different from the others. So that's what the objective is. Now we are going to look into R, that how exactly this calculation happens. So here I have the same data, wherein I have three groups A, B and C, and essentially all values are same: 237, 26, 237, 26. So I am using the same data. So we have three groups, group A, group B and C. The last element of group C is 15, that is 15. So last group of
Just a quick info, guys. If you are looking for data analytics course, then we have a good news for you. Intellipaat is providing an advanced certification in data analytics for business with IIT Madras. The course is of very high quality and very cost effective. The course link is given in the description below. Now, let's continue with the session.
the last element of group C is 15. So this is what I'm going to use the same data, and we'll try to figure out that the computation which we did in Excel, is it exactly the same which is coming into the R. So now I am running summary. Summary help us to get information about each and every variable. So it is saying that there are two variables, one is group and second is score. So in group there are three elements A, B and C, and there are three members, that is three groups are there, and inside each and every group there are five elements, that is five members. We are going to use structure function which give us information about the type of variable. So essentially for ANOVA is run between a categorical and a continuous variable. So categorical is here group A, B and C. So categorical variable in R is called factor. So whenever there is categorical variable, R reads it as a factor. So it is sometimes it is not as default, so we need to make it into the factor. But essentially for ANOVA, your variable must be factor. One variable must be factor and another variable must be continuous. Continuous is a number wherein we can perform certain mathematical calculations like 2, 3, 5, 7, the value comes in. We are using the name function to find out the name of the variables. So it is saying that the name of the variables are groups and score. Now we are going to run ANOVA. So for ANOVA, the function is AOV, and inside that we use the continuous variable, that is the score. With a tilde sign we write group. So we are saying that my score is dependent my score is dependent variable and group is independent variable. So remember, dependent comes first and independent comes second. Why I'm saying dependent and independent, this will be better explained in regression and logistic regression section. But here essentially at this moment I would say that your continuous comes first and then categorical comes second. So that will help us to exactly find the the positioning of the continuous and the categorical variable. Then we are saying data is equal to CALC. The CALC data which we created, that is the object which is in my R environment, I am using that CALC. So we need to understand the structure of ANOVA. So here we are creating an object called example, and this object is created by help of a function called AOV, that is ANOVA. Inside that function we are supplying two different arguments. One argument is the variable association, that is which one is continuous variable, which one is categorical variable, and the second argument is the data set, that on which data we are going to use it. So now I run example. So an example object is created in my environment. Now I want to see in detail about.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following method creates a new array object that looks at the same data? A. View. B. Copy. C. Paste. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
About the output, the object which I created. For that, there is function called summary. So the moment I run summary, I get the entire information about ANOVA. So it is saying that there are two groups and there are 12 elements. So how these elements are? This 12, we saw that how this 12 is calculated. That is total number of elements minus total number of groups minus 1. And we essentially saw the sum of the squares for group is 203. Sum of the squares for the group is 203. Then for the residuals, that is for the individual, it was 54. So for individual it was 54. Then we computed some F value, 22.59. That is 22.59. This is given into. So now here we are getting that what all we computed, that is coming exactly the same in our environment. So why I explain Excel spreadsheet? Reason being, it helps us to understand the different steps being computed. So here in R, we get simply the output. But how is the background, how that computation happens into the background, that is essential to know. So that's the reason that we perform manual computation, as well as we perform a computation using the R functions. Now, here we are getting 3 asterisk. So 3 stars is given. It is saying that the groups are, at least one group is significantly different from other group. So remember, null hypothesis for ANOVA is there is no statistical significant difference between the groups. That is, the difference in the mean of each group is almost zero. So there is no difference in their mean, or we can say that all means have the similar kind of distribution, wherein the alternative hypothesis says that no, at least one mean is different from others. So here we are rejecting the null hypothesis and we are saying that at least one mean is different from others. So now the question is, which mean is different from the others? We know that there are 3 groups, A, B and C. Statistical output is saying that at least one group is different from the others. Now the objective is to know that which group is different from the others. For that we have another example. So for that we are going to use some data which is available on some website, and we'll extract those data, and by help of that data we'll run the same ANOVA function. So here there is a data set available on the website. So the location of the path is given, that where exactly this is available. So we are saying that http personality project.r.org r datasets, likewise information is given. So from here we are extracting the information and creating an object called data.ex1 by help of a function called read.table. So read.table help us to read these values, and we are specifying the object which is created here. So there are two ways possible. Either we write the entire value which is written inside the balance quotation mark. We simply copy this entire content from here to here and put it here, or we write like this. So first we create an object which is equivalent to these values, and then put that object inside the read.table function, and essentially we say header is equal to true. Header is equal to true means we want to read the value with the variable names. So that's what header is equal to true. So in a spreadsheet, suppose there are, usually in spreadsheet the first row is about the variable name. So in that case we need to say header is equal to true. There is some alternate source of data wherein we normally do not get with the headers. So in that case we need not to read data with the headers, but here the essential requirement is to read the data with headers. So that's the reason we are saying header is equal to true. And again we are using the same AOV, that is ANOVA function. So inside that data, the data which we extracted, there is a continuous variable called alertness, and there is a categorical variable called doses. On that we are running ANOVA. So here we are doing the same stuff. We are creating an object using this HTTP option. Then by help of that object, we are creating another object called data.exe. So that object is created. If we want to see the structure of the dataset which we created, that is data.exe1, so we can see the structure. So structure says that there are two variables. One is doses, that is factor, and second is alertness, that is integer, that is continuous. if you want to say in detail, so this is the variable. This is exactly the way we saw in previous case. So there are different groups for the doses, and there are different alertness. So this is one is the categorical variable, and second is the continuous variable. Now we are running the ANOVA function, that is AOV, considering alertness as it's the continuous and doses as the categorical. So an object called AOV.ex1 is computed. Now we want to see the summary, the way we saw the previous summary, wherein the entire residual, some of the squares, f value, everything comes in. So the moment I run it, it is saying that the probability is 0.0298, and here there is double star. It is saying that we are going to reject the null hypothesis, that is at least one group in the given data is different from the others. So that's what this asterisk, that is star mark, indicates. Even by looking at the probability value, if this value is less than 0.05, so in that case at 95% confidence or at 5% significance, we reject the null hypothesis. So essentially we are doing the same stuff here. We are saying that no, there is at least one mean into the data, that is one group in the data which is statistically different from the others. So that's what the interpretation is. So here we can, by looking at the output, we can say that there are three groups, and essentially this value is 15 is what? This is total number of observations minus total number of groups minus 1, and this is sum of the squares within group, total group, and essentially this is how f value is computed, the way we saw into the previous case. Now the question is, here in the output we got that at least one group is different from the others, but essentially which group is different from the others? For that there is another test called 2k test, 2k. So we run 2k test on AOV.ex1 to get the difference, that which one is exactly different from others. So we are running 2k test here. So now the best part with this test is it prints a group wise comparisons. So it is saying that when we compare group B and group A, we are getting that probability value is 0.2768. That is what, as I mentioned earlier, that if this p value is less than 0.05, so in that case we reject null hypothesis at 95% confidence or at 5% significant, and say that both groups are statistically different. But in our case this value is greater than 0.05, so we cannot reject null hypothesis, and we say that no, group B and group A both have the similar kind of distribution, that is we cannot reject null hypothesis in case of group B and group A. Now, so this is called group wise comparisons. In second group comparison, that is C and A, the value is less than 0.05. So here it says that no, group A and C are statistically significant from each other at 95% confidence or at 5% significance. So group C and A are statistically different from others. Now next comparison between group C and B. Again we are getting this value is less than 0.05. So we can say that group C and B are statistically different from each others. That is, we reject the null hypothesis in case of group C and B, and we can say that group C and B are statistically different from each others. So here one thing is very clear, that group A and B are similar, whereas the group C is different from A and B. So we can say that group C is statistically different from group B and group A. Let's see it visually. So that's what we run. So when we run this code, we got the summary output, and on top of that I run 2k HSD test to find out the group which is significantly different from others. So in previous case, when we run summary, we got some information about doses, their mean value, their F value, is it significant or not. So we saw the same output coming in our previous case. Now we are going to inspect manually that how is the mean behavior of each and every group. So now, considering this AOV.ex1, what exactly we're trying to do here? This is my grand mean, that is overall mean. This is mean of group A, this is mean of group B, and this is mean of group C. So we have three different groups, and here we come to know about the mean of each and every group. Now second option is to get the similar, to get some visual information about the groups. So here we are running the box plot. So box plot for all three groups. So this is for group A, this is for group B, and this is for group C. So here we can say that for group A, the mean is lying, this thick black line is the mean value. So even visually we can see that group C is different from group A and group B. That is what coming in my output as well. So this is what we run. We run the mean of the all three groups, and the moment we run the box plot looks like this, the way we saw. So even box plot is a good way to visually inspect the behavior of the data, the behavior of means, and how values are coming across. Now we are going to talk about two-way analysis of variance, wherein in previous case we had only we had two variables. One was continuous and second was categorical. In this case, we are going to consider multiple variables together. That is, essentially there is one group, and for that group there are multiple variables. So it's not, in previous case it was group and doses. Here we are going to consider, apart from doses, there is one more variable. So we are going to see the impact of different variables on the groups. So is, like, suppose I'm giving one example. There is there is one publication which publish books on math and physics. There is another publication which publish book on math and physics as well. One school use one publications, another school use another publications, and the student of both the schools appear for state level or the national level examination, and now we have a score of the students. We are going to check that is there any kind of statistical significant difference exist between both publishers group. If we we assume that book is the only important factors which contributes into the final score which we get into the examination. Fine. So here assumption is the book is the only factor which affects the score which we get into the examination. Right. So in books we have, so book is one variable, publisher is one variable, and for publisher there is math score, there is physics score. So for publisher 1 there is math score, physics score. Publisher 2 there is math score, physics score. Now we are going to compare publisher 1 and publisher 2 by help of math score and physics score. So in previous case it was only one group and one continuous variable. In this case we have multiple groups and multiple continuous variable. So again we are using some dataset available on the website. So we have gender information, male and female, and we have doses. So different kind of dose was given. So there are two types of dose, A and B, and there are two types of gender, male and female. So for male, dose A and B both was tested. For female, dose A and B both is tested, and for that we have their result. This result, so we are going to compare that how is the impact of doses on different genders when we consider alertness as the as a continuous variable. So again we run the same function, that is AOV. Alertness is what? It's my continuous variable, and we are using gender and dose. So remember, whenever we have more than two variables, we write like this. So the moment we write like this, we get individual impact as well as the combined impact. Combined impact is what? Gender and doses both together. So we'll get probability value for gender, we'll get probability value for the doses, and at the overall level we get the probability value for gender and doses both together. Let's see that. So this is summary of ANOVA, which says that for gender this is the probability. So if I consider gender as standalone, I can say that no, it is not statistically, gender is the impact of gender on alertness is not significantly different. So I cannot say, because this value is greater than 0.05. So we fail to reject null hypothesis. In case of doses, the value is 0.666. Again, this is more than 0.05. So here we fail to reject the null hypothesis. Now, this is called interaction impact. So here, this is interaction of gender and doses. So if both comes together, this is also not significant. So here we can say that no. The output is saying that no, none of the variable is significantly different from the others. So this is how our observation looks like. This is how the data is. When we run the summary, when we run the ANOVA and on the summary, we saw like this, values were coming with certain degree of freedoms and doses. So that all we saw, and I explained that what is the meaning of those all values. Now we are going to print the mean of each and every group. That how exactly mean looks like. It says that the mean for the grand mean is 14.06. The mean for gender female is 16.25, and for male this is 11.88. In terms of doses, if you talk about dose A, the mean is 13.50, and for B it is 14.62. Now, if we try to find out the mean of doses on different combinations, like for female and dosage type is A, so mean is this. For female dosage type B is this. For male dosage type A is this, and for female dosage type B is 12.50. So likewise, this is a kind of cross tabulation wherein we have entire information about each and every cell or each and every component. Now let's plot the box plot. The moment we draw the box plot, we get those entire information. It is saying that this is the mean of A and F, that is type doses A for the female, doses B for the female, dose A for the male, and dose B for the male. So this is how the box plot looks like. So even if I compare the mean of, let's compare with the A and B with female. So these are very close to each others. That's the reason that there is no statistically significant difference was coming across. Even for A and male and B and for male, though the dispersion for the, you can say the range for B and male is quite high, still their mean value are very close to each other. So that's what we are getting here. Now we are going to talk about K-mean clustering. This is essentially a way to classify different elements so that we come to know about the behavior of those elements. So exactly what is clustering? The process by which objects are classified into a number of groups so that they are much dissimilar as possible from one group to another group, but as much similar as possible within each group. So essentially what we are saying, that the moment we classify different objects and we bring them into certain groups, so the element inside the group are very similar to others, but the element outside the groups are not similar to others. So that is how the process is. So in other words, the cluster analysis mean dividing the whole population into group which are distinct between themselves but internally similar. So that is how the clustering algorithm works. So the object in group 1 should be similar as possible, but there should be much difference between the object in group 1 and group 2. So group 1, the object inside group 1 must be similar to each other, but the object from group 1 and group 2 must be dissimilar to each other. So the attributes of the object determine which object should be grouped together. So now we are going to talk about the attributes which help us to determine about the grouping of the element, that which element will come inside which group. Here one example of current balance and gross monthly income is given. So the lot of individual information is available with us. We simply put in a scatter plot and we try to figure out that which all element we can group together to give a common feature to the entire group. So we are creating two clusters. There are possibly so many clusters we can do in this case, but essentially we are creating two clusters, that is cluster 1 and cluster 2. So in cluster 1 we are talking about the high balance and low income. In cluster 2 we are talking about the high income and low balance. So the feature of these two different groups are different. So the moment we talk about cluster 1, so these are essentially high balance and low income group. When we talk about cluster 2, they are essentially the people of high income and low balance. So even by knowing, so we can give a common name to the each and every element which is coming in cluster 1. Likewise, we can give a common name for the each and every element which comes under cluster 2. So that is how the process is. So now cluster 1 and cluster 2 are being differentiated by income and cluster balance. The object in cluster 1 have similar characteristics, that is high income and low balance. On the other hand, the object in cluster 2 have the same characteristics, that is the high balance and low income. So that is how we can classify them.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following is a false statement about data analytics? A. It collects data. B. It looks for patterns. C. It does not organize data. D. It analyzes data. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now let's talk about the algorithm or the process which works when we work on k-mean clustering. So now under this procedure, you need to pre-specify how many clusters you want to consider. So here the essential requirement for k-mean clustering is to decide the number of k, that how many groups we are going to consider. That's the reason it is called objective segmentation. So clustering is a kind of segmentation, and k-mean clustering is objective segmentation, wherein we specify certain groups and certain clusters, and accordingly we proceed. So in step 1, we partition the item into k initial clusters. So what exactly we do? We simply partition the entire population into, suppose we are going to have 4 clusters, so divide the entire population into four groups randomly, like suppose it is like a plane of paper, it's a plain paper. So in that case, simply fold paper in a way so that we create 4 different, you can say, corners. So we have 4 different squares. The moment we fold the paper, twice, one in horizontal and second time in vertical, we'll get the 4 quadrants. So likewise, you split into 4 quadrants, then scan through the list of n items. Then we start scanning each and every element from the list to figure out that a particular element is suitable for which of the groups. So it is saying that scan through the list of n item, assigning each item to the cluster whose centroid is closest. So we are talking about the centroid. Centroid is essentially the mean. So in case of paper folding examination, I say that there will be 4 quadrants. So we can easily find the mean of each and every quadrant, and then try to find out that which value is closer to which mean, and accordingly we align them. To scan through the list of n items, assigning each item to the cluster whose centroid is closest. Then each time an item is assigned, as well as relocate the cluster mean or centroid for the cluster receiving that item and the cluster losing that item. So exactly, it's an iteration kind of process, wherein every time we assign a particular element to some cluster, and the next time we try to shuffle it with other clusters. So repeat the step 2 over and over again until no more assignments are made. So that is, we try to come to an optimal solution wherein the difference between the cluster mean and individual value is least. So that is called the optimal solution. We are going to take some example for that. We are using some random numbers. We are creating random numbers of 100. We are saying standard deviation is 3. that is 0.3, and I'm saying that number of column is equal to 2. So essentially I'm creating a matrix. If you remember my matrix part, wherein we talked about how what are the essential element of a matrix. So here we are saying that we are going to use random numbers with standard deviation 3 and number of column is equal to 2. If I simply run this part, I want to show you the matrix. How does it look like? So this is your first matrix, wherein we are saying that there must be 100 elements with standard deviation 0.3 and number of column is equal to 2. So essentially there will be 50 rows. There are 50 rows and each row consists 2 element. So 50 multiplied 2 is the 100. So total element is 100, what it essentially saying. And the standard deviation is given. So we are generating a random number with standard deviation 0.3. We are creating another matrix of 100 element. This time we are saying that mean is equal to 1 and standard deviation is 0.3. And again we are saying that number of columns is equal to 2. So if you look at this matrix, so this is a 50 by 2 matrix. Now I saw you the individual matrix, but now what are we going to do? We are going to use a function called rbind, that is row bind, and with the row bind we are clubbing both the matrix together, and we are giving name to this matrix as x. So we are creating an object x, which is combination of two matrix, and we are performing this combination by help of rbind. So here we have created an object x. If you want to see more about this object, this is how this object looks like. This object is combination of two matrix. In first matrix there were 50 rows, in second matrix there were 50 rows. So this object has 100 rows. So there are 100 rows in this object. And this is combination of the previous two matrix that we saw. Now you see there is no variable name. It is saying v1 and v2, that is the default variable name for a data frame. Now what are we going to do? We are going to name this variable. I am saying we are giving column name to x, that is x is my object name. I am giving column name to x and saying this first column name is x and second column name is y. So now if you look to the x, there is x and y is written. So even name of my object is x, whereas inside the object there are two variables and the name of those variables are x and y. You can choose any of the name. It is not essential to have x as the name of the variable as well as x as the name of the object. So technically it should not be, but we can do that way as well. Now I'm going to plot of x to see that how is the scatter plot. So essentially we are going to plot and scatter. So you see this is x and this is y. So essentially if I need to create some cluster, I can say that this area is a kind of cluster whereas this area is a kind of cluster. So even by visual inspection we can say something about the behavior of the clusters. But now that's what it says. We use rbind function, we use column names, and we saw the value, that how the value of x and y is coming. Now we are going to run the algorithm of k-mean algorithms. So essentially for k-mean algorithms, the function is k-means. Then for this function, we supply two arguments. First argument is the data on which we are going to run this, and second argument is the number of clusters we are looking for. So here we are saying that I'm going to run k-mean clustering at variable x, and essentially I'm interested for two clusters. So it creates an object called CL, wherein there is complete information of my cluster. If I simply run this, I will get the entire information. It is saying that there are two clusters. In cluster, the mean for cluster 1, the average value of x for cluster 1 is 0.97, for y is 0.9791, for cluster 2 x mean is this, y mean is this. Likewise, we have a lot of information. We are going to discuss more and more about these informations. Now we are going to have information about the center coordinate of each clusters, the first part which we saw. So it is saying that for cluster 1, the x coordinate is this and y coordinate is this. That is where exactly the centroid of my cluster is. Now if I want to see the element wise cluster information, that which element fall under which cluster, so for that, remember, there is clusters and there is cluster. The only difference is S. So here I get element wise information. So it's saying that first element is in second cluster. Likewise, 89th element, it is talking about 89th element is in cluster 1. So likewise. Now we are going to plot. So that is what we saw by help of the clusters. Now we are going to plot these elements together. So for that we have function called plot. So I'm running this plot. So here that plot is given. So remember, whenever we plot a cluster, we need to specify the colors. I'm saying color is equal to CL cluster. So it takes the default colors. It can take any color, but essentially different clusters are denoted by different colors. So it is saying that this is under cluster 1 and this is cluster under cluster 2. So red spots are inside cluster 1 and black spots are inside cluster 2. Now if you want to exactly see the centroid of these clusters, this is simply the scatter plot. If you want to see the centroid of each cluster, so in that case we need to use function points. For point, I am saying that I am interested about CL cluster. I am saying color is equal to 1, 2. Essentially the moment I use color, so this is 1 is for the red and 2 is for the black. So I am saying color is equal to 1, 2. PCH is equal to 8. I am saying PCH is what kind of symbol I am going to use. So every PCH is associated with different symbols. So the cluster, the centroid will come with different symbols. And then I am saying CEX is equal to 2. That is, I want to inflate the size of the centroid. That is the symbol in which the centroid is specified. I want to increase that size by 2 times. See here, it is saying that this is the centroid of this cluster. So there is star inside both the cluster. This is saying This is centroid of first cluster and this is centroid of second cluster. So now we can see that the centroid of the different clusters. Now, I was talking about the colors. So if you want to change the colors, this time I'm saying color is equal to 2, 3. So remember, 1 was used for red and 2 was used for black. That is default. Now I'm saying 2, 3. So in this case, you see how the color of the cluster has been changed. So now the color is changed to green and red. So that is what the application of COL with certain combinations is. So accordingly you can do R&D and discover more and more symbols available with us. If I do this Cx is equal to 4, then what will happen? See the size of the stars, it grows up. So it is saying that I am increasing size of the star to 4 times of the normal. If I do Cx is equal to 1, so in that case it will be of the circle size, the size of the circle. Let me clean it first. This is what I plot. The moment I do Cx is equal to 1, so see, the size of the star is exactly to the same size of the circle. So that's how the application of Cx is. If I change this from 8 to 7, so in that case we'll get some other structure. So here if the box is coming, so PCH is it's essentially the shape of the point that is supposed to come in the output. That's what we talk about. So here we generated certain points. On top of the points we specify some color options, that is color 1 and 2. Then we talk about the shape of the object that which we are going to create. Then essentially we talk about that how many times I'm going to inflate it. So this is all about the k-mean clustering. So here the entire write-up is given, the Cx indicating the amount by which the plotting text and symbol should be scaled relative to the default. 1 is the default, 1.5 is the 50% higher, and 0.5 is 50% smaller, etc. Likewise, same time we can try with the different options. In previous case we talked about cluster 2. Here we can talk about cluster 3. So here again it is giving me 3 coordinates. If I plots, so we are getting 3 clusters in different colors. They are the centroid of different clusters. So likewise we can understand, we can create any number of clusters, but for that it is essential to know the number of clusters which we are going to create. So there are in high-end analysis there are ways to find the optimal k value, but here at the beginning we usually get number of clusters because this number of clusters are pre-tested in some of the previous experiment, and on the basis of those experiment these numbers are decided. So we need to consider the same framework for the cluster creations, and that is how it is coming. So if I talk about the technical interpretation, so here 3 cluster solution is not looking very ideal because these 2 clusters are very you can say these are not coming exactly separated. So if I use 4, so probably 4 cluster will give me a good solution. So now 2 cluster solution, 3 cluster solutions, 4 cluster solutions, which one is the optimal? That is that is evaluated by the experiment. Here, as a analyst or as a statisticians, we need to follow the guideline for k-mean clusterings, wherein the clusters are pre-specified, and accordingly we need to proceed. So this is all about the clusterings, how clusterings are made, and how clusters solutions are done.
Now we'll understand the difference between a data analyst and a data scientist. So starting with data analyst, so we already know data analysts collect data from various sources, or they can be primary or they can be secondary sources. They pre-process the data, they clean the data, manipulate and also visualize the data. They performs big data analytics on the data, they create reports. Then a data scientist collects the data, collects the analyzed data and looks it with an angle of creating such a process that helps in building automated models, that helps in the prediction for the business. And also the task of a data scientist is to analyze and visualize the data and decide about which algorithm should be used. So this is the major difference between a data analyst and a data scientist. Now moving on to the next part, that is we will look into the skill set of data scientist and data analyst. So starting with data scientist, so a data scientist should have knowledge of SQL, that is the structured query language used for databases, then Tableau or Power BI, that is used for data visualizations. So they must have knowledge of these two tools in Microsoft Excel. Then going to the programming languages, they should have a comprehensive knowledge of Python as well as R. So there are various libraries in Python and R both, various libraries and packages that are specifically used in data science, machine learning and artificial intelligence to analyze and visualize the data, to create machine learning models, create automated models. So they should have knowledge of both these languages. Then mathematics, a data scientist must have a thorough knowledge of mathematics, especially statistics and probability, linear algebra, calculus, differential equations, because these are used for creating machine learning models. Then data pre-processing, manipulation and visualization, these are the basic tasks of a data scientist. So they should be thorough with data pre-processing, manipulation and visualization tasks. Then machine learning algorithms, so they should be an expert and in implementing various machine learning algorithms on the data sets, so that they can create models, predictive models out of that. Then they should have knowledge of artificial intelligence, which includes neural networks and deep learning. The knowledge of neural networks and deep learning is very important for a data scientist to know. Then obviously software engineering, they should have a knowledge of software engineering as to build work on various softwares, creating softwares. Then finally they should be a good problem solver. Now moving on to the next part, that is skills of a data analyst. So they also should have knowledge of SQL, that is structured query language, then Tableau, that is used for data visualization, then Microsoft Excel, then programming languages. They should have knowledge of Python or R, that is used by data analysts to perform various analytics techniques. Then statistical knowledge is must for a data analyst, as statistics is used for analyzing the data and applying statistical techniques to understand the insights of the data. Then a data analyst should also be a good problem solver to analyze the business problems, to solve the business problems and make effective strategies for increasing the revenue generation of a business. Then ability to analyze, model and interpret the data. Then They should also have basic knowledge of data science, then machine learning algorithms, so that they can collaborate with data scientists and ML engineers for building predictive models. Then comes creating dashboards and reports for the organization so that everyone can understand about the trends and patterns of the business data, to know the insights of the data, and to understand in which direction the business is actually going. Now we will see the job scope and salary of data analyst and a data scientist. So starting with data analyst, according to Forbes, in India there are 5,000 plus jobs available for a data analyst in 2020. And talking about United States, the number of jobs are more than 12,000. So you can see there are a plethora of career opportunities in the field of data analytics. Talking about average salary, so in India, the average salary of a data analyst is 7,50,000 per annum, and in the United States, it is $1,15,500. Then moving on to the data scientist, talking about number of jobs. According to Forbes, in India there are 10,000 plus jobs available for a data scientist in 2020. And in the United States, the number of jobs are more than 25,000. So there is a wide scope of opportunity in data science field also. So people who are willing to become a data scientist, so there are a plethora of opportunities that you can grab. So talking about average salary, a data scientist earn an average salary of 9,35,000 in India, and in the United States it is $1,32,000. In this video, we understood why we need to handle data, what is the importance of data with the help of the example of Google Maps. Then we looked into the roles and responsibilities of data analyst and data scientist. Then what are the skill set that makes a data scientist and data analyst. After that, we understood the difference between a data scientist and data analyst. And finally, we looked into the job scope and salary of both these profiles. So this is all you need to know about the difference between a data analyst and a data scientist.
Let us begin with the very first skill, that is statistics. So statistics is the discipline that concerns the collection, organization, analysis, interpretation and presentation of the data. So now the question arises, why do we actually talk about statistics when it comes to data analysis? So for this, you need to understand what data analysis is. So data analysis is the process of systematically applying statistical or logical techniques to describe and illustrate as well as evaluate the data. So an essential component of ensuring data integrity is the accurate and appropriate analysis of research findings by using the data you have. And it is the actual, or you can say the main objective of data analysis is performing the analytical and logical reasoning to gain the information from the data. So for this, we use charts, plots, graphs and various evaluation metrics, or you can say the parameters, such as calculating the average, mean, median, mode or standard deviation, or it could be variance. So can you imagine the importance of statistics? Imagine we do not have statistics for the data interpretation or evaluation. So how can we analyze the data? There is no way to analyze the data. That is why statistics is one of the important, or you can say the major component in the field of data analysis. Also, you should have the basic knowledge of mathematics also, including linear algebra or a little bit of calculus, and also the knowledge of probability. So this is the first skill that you must have. Now let me go to the next one, that is programming language. So for any IT field or across various industries, we use various kinds of softwares and applications. So how they are actually built? Using programming language. So they are built using programming language, one or the another. So there are various programming languages such as C, C++, that are the basic ones. So if you are starting with any programming language, you can just go through C and C++ first, because they are the starting point for any programmer who is actually willing to do programming. Then comes Python, Java and R. So talking about data analysis or data analyst, so two of the famous or popular programming language that you can say are Python and R programming. So it provides various types of libraries, packages and tools that actually helps in the data analysis process, data manipulation, data pre-processing, cleansing, and even creating machine learning models, artificial intelligence, to build AI based models. So these two are the programming languages you must go through while starting with your data analysis career path. So this is about the programming language. So also you can use Java. Java is one of the widely used and a popular language. So Java is an object oriented programming language and it can be used to create complete applications that can run on a single computer or be distributed across various servers and clients in a network. So you can use it to easily build mobile applications or run on a desktop application, along with using it for different operating systems as well. But in comparison to R and Python, it is not actually built for data analysis. So there are specific libraries and packages in Python programming and R programming that helps to analyze the data, it helps to produce beautiful graphs and plots that gives some insight or information about the data. So that is why we use Python and R programming for data analysis. Now let us move on to the next skill that you must have. So data cleansing, data manipulation and visualization skills. So this is among one of the most useful skills that you must have. So data cleaning, data manipulation, data visualization, and there are different Python libraries such as Matplotlib, scikit-learn, pandas, seaborn, scipy that actually helps in performing all these operations. So the question arises, why do we actually need to perform cleansing of the data manipulation and visualization? So actually in the real time, the data is always present in the unstructured form that contains null values, some unusual values or errors that may lead to the generation of a model that predicts a wrong output. So we create applications, we create machine learning models, put the data into it and get some results out of it. So when the data is having an error, so it will not be good for us as well as for our business because the prediction will be wrong. So that is why we have to perform various techniques for cleansing the data, removing those types of values that may lead to error, then performing manipulation to the data so that we can make the data understand to the machine. So we can make the data actually in the form such that machine can understand it, and then perform visualization. So we should have knowledge of various Python libraries that you can see such as pandas, seaborn, scipy, scikit-learn, matplotlib to perform such task. Now let us move on to the next skill, that is databases and BI tools. So talking about databases, a data analyst must have skills or must have knowledge of SQL, MySQL, SQL servers. So actually when data is collected by a data analyst from the company, or you can say from the database of the organization, so it is in the unstructured form and there can be too much back and forth for collecting the data, visualizing it, analyzing it. So there are many tools available such as Power BI, Tableau, ClickView. So these are the tools that are actually used for data analysis, or you can say these are BI tools. So these tools have the connector to the database, and to fetch the data from the database, the data analyst must have knowledge of SQL programming language or MySQL or SQL Server. So that is the actual use of, or you can say the skill that is needed by a data analyst for database and BI tools. So they must know or they must have knowledge of any one or.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following method creates a new array object that looks at the same data? A. View. B. Copy. C. Paste. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
They can have more also, but Power BI, Tableau and ClickView, they should have knowledge of that, because various companies uses these tools for data analysis, visualization. So maybe one company would be using Power BI and another one would be using Tableau or ClickView. So you should have knowledge of that also. Now coming to another technology, that is big data. So big data is a technology that is actually used for handling huge amounts of data available, that is real time data, and actually it is used for storing and processing big data, as the name suggests, that is huge volumes of data. So there are various tools such as Hadoop, PyDoop, Hive, Spark, and PySpark, Dask. So these are the tools that actually help us to handle big data, and one of the most famous tool is Hadoop. So in Hadoop, data is stored on inexpensive commodity servers that run as clusters, and it is a distributed file system that allows concurrent processing and fault tolerance. So it is actually a programming model that is used for faster storage and retrieval of data from its nodes. So it is actually a very helpful tool in the field of data analysis as well as for data analyst. So this is one of the skill, or this is one of the tool and the technology for which you must have a thorough knowledge. Now moving on to the next one, that is Excel. So Excel is a handy software that can be used to store and organize many data sets. So we need to have data, we need to analyze the data. So where do we first store it, or where do we fetch the data and then store it? So this is Excel, where we store that data in a systematic way, or you can say in a structured way. So it is a very useful tool, and using its features and formulas, we can actually use the tool to make sense of our data. So for example, you can use a spreadsheet to track the data and automatically see or you can perform various operations. You can add the operations such as mean, average, sum, total, difference, and actually you can see them automatically when you go from one column to another column. So what is the actual purpose of the Excel is to store the data, and we can add some functionality, or we can store it in a structured way. So it is a spreadsheet program in a simple language. That means it is used to create grids of text, right, and numbers as well, and formulas specifying the calculations. So that's extremely valuable for most of the business nowadays. So businesses actually use it to record expenditures, income, plan budgets, chart data, and perform data analysis or data manipulation visualization by using the data stored in these Excel sheet. So this is the use of the Excel. You can also perform VLOOKUPs, pivot, power pivot, macros, and there are many such functionalities or operations in this Excel application that you can use. So this is a must to have skill for any data analyst. Now moving on to the next skill, that is machine learning. So you must have heard about machine learning. So what actually machine learning is? So machine learning is simply an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So machine learning focuses on the development of the computer programs that can access data and use it to learn for themselves. So it is one of the wonderful application of artificial intelligence, and it is one of the trending technologies in this era. So the question arises, so why should a data analyst know about machine learning? So the answer is, in a company's research team, which actually works on the data interpretation, and business analysts are there, and data analysts, data scientists, machine learning engineers, AI engineers. So they all need to collaborate with each other to know about the data, to know about the product, or to know about the application which the company is using or creating for the customer. So it is good to have specific domain knowledge, but the question is, you have to have knowledge about the entire product. So that does not means that you should have the skills related to data analysis itself, or you just have the knowledge of Tableau or ClickView or Power BI and you become a data analyst. It is about knowing the entire product. So you should be multifunctional. That is why it is recommended that machine learning should be a domain, or machine learning or a data analyst must know about machine learning. because a analyst need to collaborate or coordinate with the other team members as well, that consist of data scientists, ML engineers, AI engineers, business analysts, to explain them about the data or to explain about the data analysis that they have made or any idea that they have, also for building the application or the end product that the customer wants or the company wants. So they should have knowledge of machine learning. So roughly the task of a machine learning engineer is also to analyze the data, to visualize the data, and then build models. So the task of data analyst is also to analyze and visualize the data. But then after the analysis of a data analyst, the machine learning engineer looks into the data for building the model's perspective. So this is the perspective difference between both of these professionals. Now moving on to the next very important skill set, that is not technical, it is a non-technical skill which is very crucial for any professional including data analyst, that is communication skills. So imagine you have a thought, you cannot express it, you have the knowledge, you cannot represent it, and you have the story but you cannot tell it. So you do not have appropriate skills to represent your knowledge, to explain someone a simple thing. So that is where the communication skills come in. So you should have an outstanding storytelling skills, and you should have skills to represent your facts and explain the business analytics to your team members or the business owner. So at the end you have to explain it to a non-technical person, because the person who is running the business, if he or she is not having a technical knowledge about the field, you should have the skills to communicate with them, to explain them the reality or the data analysis you have made for their business in a layman terms. So that is why communication skills is one of the important skills that you must have apart from the technical skills for a data analyst. So communication skills plays a major role for a professional in the industry. So that is why this is one of the, or this is considered as one of the most important skill. Now moving ahead to the next very important non-technical skill in the queue is creative and critical thinking. So brainstorming and profit boosting ideas and customer binding strategies or plan is one of the important subpart of creative and critical thinking. So the end goal of any data analyst or a professional working for their organization is to give them business. So they can do this by solving real life business problem for the business, so that they can boost their profits, they can increase their customer retention, as well as they can bind their customer for using their products. So you can ask a basic question to yourself. The world is complicated. Do you have a creative mind so that you can solve the problem or a critical problem with a simple solution? Do you have a creative mind so that you can solve a simple problem with a very creative or a critical algorithm so that it can work efficiently for the business organization? So this is the skill that you definitely want for existing or for making your existence in the industry. Apart from that, critical thinking enhances language and presentation skills as well. So this thinking clearly and systematically can improve the way we express our ideas. And in the learning process and the process of getting the knowledge, it helps us to know and understand how to analyze the logical structure of text, and critical thinking also improves comprehension abilities. So that is why it is one of the most important skills, and it comes in the top 10 skills for becoming a successful data analyst. Now going to the last skill that you need is business knowledge. So there are thousands of companies in the world. So I'll talk about few of the top companies and I'll be taking example of these companies. So all these companies have different set of customer, they have different vision, they have different objectives. So talking about Amazon and Flipkart, they sell their product. So their target customer is the audience that are willing to buy specific products such as shoes or pen, laptop, mobile, or any other product. Whereas Google, YouTube, Facebook, and Twitter has some other set of customers. So talking about Google, it has the entire world as its customer. So we search anything we have to search, we use Google. So it is a search engine. Talking about YouTube, we search videos and we use it for the entertainment as well as gaining knowledge. So its purpose and the objective is different. Then coming to Facebook and Twitter, they are social media platform. So we use them to actually connect with the people. And it is also a source of accessing information, providing information, sharing information, and communicating with various people all across the world using social media. So tutors and students can be connected to each other and can make a good use of these platforms for the benefit of their learning as well as teaching. It is also a platform used for marketing and putting advertisement also. So this is the main purpose of these social media platforms. So all these companies are different and all their objectives are different. So professionals working for these companies should have the knowledge of entire product. So talking about the Amazon, so they must have knowledge of what all technology they use, what is their business plan, and everything they should know about. And for Google, how a search engine is built, how Google uses algorithms to show the data that is search that we search. Same with YouTube, same with Facebook, Twitter, and Flipkart. So the professional working for any organization must have a thorough business knowledge and how actually the product that the company is giving, how actually it works. So for example, a company is selling clothes and they have to build an application, an Android application as well as a web application, but the developer doesn't know that what product the company is selling. So he will or she will build the product according to her skills, or the product will not meet the requirements of the company. So this should not be the case. The developer or any professional who is working for the company should have a thorough knowledge, or you can say the business knowledge. So these are all the top 10 skills that are actually required for becoming a successful data analyst. And I hope you now know the necessity of each of these skills that are required for data analysis or for becoming a data analyst.
Just a quick info, guys. If you are looking for data analytics course, then we have a good news for you. Intellipaat is providing an advanced certification in data analytics for business with IIT Madras. The course is of very high quality and very cost effective. The course link is given in the description below.